Imagine discovering that everything you thought you knew about the universe was wrong. Picture galaxies that existed when the cosmos was barely a toddler, black holes that literally drag spacetime like thick honey, and astronauts whose hearts transform into perfect spheres in the alien environment of space. The reality beyond our pale blue dot is so bizarre, so fundamentally alien, that each new discovery forces us to question the very nature of existence itself. 1. Baby galaxies that broke physics. When the James Webb Space Telescope peered deeper into space than ever before, it made a discovery that shattered our understanding of cosmic evolution. Scientists found galaxies like Jade's GSZ 14-0 that existed when the universe was merely 280 million years old, a cosmic infant at just 2% of its current age. These ancient galaxies were already massive, complex structures with active star formation, spiral arms, and sophisticated organization. It was like finding a fully grown oak tree in what should have been a nursery of seedlings. According to every model of cosmic evolution, these galaxies should not have existed. They had somehow assembled from primordial gas clouds and grown to maturity in what, cosmically speaking, was the blink of an eye. This discovery forced astronomers to completely reconsider the timeline of cosmic evolution, proving that the early universe was far more dynamic and rapidly evolving than anyone had imagined. 2. Ancient galaxies looked surprisingly modern. Deep in the cosmic past, over 12 billion years ago, astronomers expected to find primitive, chaotic collections of stars, cosmic teenagers still figuring out their identity. Instead, Webb revealed something extraordinary: galaxies that looked remarkably similar to modern ones. These ancient stellar cities already possessed elegant spiral arms, distinctive central bars, and sophisticated ring structures that scientists believed took 6 billion years to develop. It was like discovering that medieval towns had skyscrapers and subway systems. Galaxy after galaxy showed mature characteristics that shouldn't have formed until much later in cosmic history. The implications were staggering. Either our understanding of galactic evolution was fundamentally flawed, or the early universe operated under different physical laws than we thought. These cosmic teenagers were actually sophisticated stellar metropolises, complete with complex architecture that challenged every assumption about how galaxies grow and evolve. The universe, it seemed, had always been far more organized and rapidly developing than our earthbound imaginations could conceive. 3. The universe may have been born inside a black hole. The James Webb Space Telescope made a discovery that supports one of the most mind-bending theories in cosmology. Our entire universe might exist inside a black hole from another universe. Webb found that galaxies across the cosmos show a preferred rotational direction. They're not randomly spinning but follow a cosmic scale pattern. This observation aligns with theories proposing that our universe began not with a traditional Big Bang singularity, but inside a rotating black hole from a parent universe. In this scenario, the torsion of spacetime from the black hole's rotation prevented the crushing singularity, instead creating a big bounce that birthed our reality. The cosmic microwave background, dark energy, and the universe's large-scale structure all fit eerily well with this black hole universe model. If true, it means we're living inside a cosmic Russian doll, where black holes in our universe might be giving birth to entire new universes, each containing billions of galaxies, stars, and potentially conscious observers wondering about their own cosmic origins. 4. Carbon-based molecules existed impossibly early. In the ancient cosmos, when the universe was only 10% of its current age, something impossible was happening. Webb detected complex organic molecules, carbon-based compounds similar to those found in Earth's oil and coal, floating in galaxies over 12 billion years old. This discovery rewrote the timeline of cosmic chemistry. These weren't simple molecules. They were sophisticated carbon structures that scientists thought required billions of years of stellar evolution to create. Stars needed time to live, die, and scatter heavy elements through supernova explosions before complex chemistry could begin. Yet here were the building blocks of life, existing in an era when the universe should have been too young and chemically primitive to support such complexity. The implications are staggering. If the ingredients for life existed so early in cosmic history, then life itself might have had far more time to develop and spread throughout the universe than we ever imagined. Perhaps we're not among the first generation of cosmic life, but part of an ancient, ongoing story of biology that began almost at the dawn of time itself. 5. Early galaxies were star formation eras. In the cosmic dawn, small galaxies were engaged in an impossible feat of stellar manufacturing. Webb discovered ancient dwarf galaxies that were creating stars at rates 50 to 100 times faster than similar-sized galaxies today. These cosmic factories were punching well above their weight, producing torrents of ultraviolet light that helped transform the early universe from an opaque fog into the transparent cosmos we see today. Imagine a small town suddenly producing as much energy as New York City. That's the scale of overachievement these early galaxies demonstrated. They were operating like stellar assembly lines working triple overtime, converting gas into stars with extraordinary efficiency. This frenzied star formation was crucial for cosmic evolution. These dwarf galaxies were the engines that cleared away the hydrogen fog left over from the Big Bang, allowing light to travel freely through space for the first time. Without these overperforming stellar factories, the universe might have remained dark and opaque, a cosmic winter that never ended. These little galaxies were the unsung heroes of cosmic enlightenment. 6. We can now see our galaxy's monster. At the heart of our Milky Way lurks a monster so massive it defies comprehension. A supermassive black hole called Sagittarius A** that weighs 4 million times more than our Sun. For decades, this cosmic beast remained invisible, hidden behind dust clouds and the limitations of our telescopes. Then, in 2022, the Event Horizon Telescope achieved the impossible. By linking radio telescopes across the entire planet, creating a virtual telescope the size of Earth itself, scientists captured the first direct image of our galaxy's central black hole. The photograph revealed the shadow of Sagittarius A**, a dark silhouette surrounded by a glowing ring of superheated matter spiraling toward oblivion. This wasn't just a pretty picture. It was proof that Einstein's most extreme predictions about space-time were correct. The image showed matter at the point of no return, where space and time become so warped that escape is impossible. We were literally seeing the edge of a cosmic cliff, 27,000 light-years away, where reality itself breaks down. 7. Black hole mergers convert mass directly to energy. On September 14, 2015, humanity witnessed the most violent event in the universe. Two black holes, each about 30 times the mass of our Sun, spiraling into each other at half the speed of light. In the final tenth of a second before collision, something extraordinary happened. 3 entire solar masses simply vanished. Not destroyed, not scattered, but converted entirely into gravitational waves according to Einstein's most famous equation, E equals mc squared. This wasn't nuclear fusion or any other process we see in stars. This was pure mass becoming pure energy, the universe's most efficient conversion mechanism. In those final moments, the colliding black holes released more power than all the stars in the observable universe combined. The energy poured out as ripples in space-time itself, waves that compressed and stretched the very fabric of reality as they raced outward at light speed. When these gravitational waves reached Earth after traveling for 1.3 billion years, they were detected by LIGO, proving that Einstein's century-old prediction about the nature of gravity was absolutely correct. 3 solar masses had become cosmic music. 8. Gravitational waves travel for billions of years. The gravitational waves detected by LIGO began their journey to Earth when our planet was still dominated by simple, single-celled organisms. These ripples in space-time traveled for 1.3 billion years across the cosmos, maintaining their integrity through the vast emptiness of intergalactic space. During their epic journey, life on Earth evolved from primitive microbes into complex multicellular organisms, then into fish, dinosaurs, mammals, and eventually humans. Continents drifted, ice ages came and went, and mass extinctions reshaped the biosphere, all while these gravitational waves raced toward us at the speed of light. When they finally reached Earth on September 14, 2015, they had compressed to an almost inconceivable scale. The waves that LIGO detected were 10,000 times smaller than the nucleus of an atom, yet they carried the unmistakable signature of their violent cosmic birth. It's as if the universe kept a perfect recording of that ancient black hole collision, playing it back for us with such precision that we could determine the masses, spins, and final merger characteristics of objects that collided when Earth was an alien world. 9. Time nearly stops near black holes. Einstein's theory of relativity reveals one of the universe's most mind-bending properties. Time isn't constant. Near a black hole, gravity becomes so intense that it literally slows the passage of time. If you could position yourself just outside a black hole's event horizon, that point of no return, something extraordinary would happen. While 1 year passed for you in that extreme gravitational field, people on Earth would experience 141 years. You could watch entire human generations live and die in what felt like months. From Earth's perspective, you would appear frozen at the edge of the black hole, your image redshifted and stretched as light struggled to escape the gravitational well. Time dilation isn't science fiction. GPS satellites experience it in Earth's much weaker gravity, requiring constant corrections to maintain accuracy. Near a black hole, this effect becomes extreme. You could theoretically use a black hole as a time machine to the future, though the journey would be strictly one way. The universe would age around you as you remained relatively young, a temporal castaway watching cosmic history unfold in fast forward. 10. Spinning black holes drag spacetime itself. Imagine spacetime as thick honey, and a rotating black hole as a massive spoon stirring this cosmic medium. This isn't just a metaphor, it's exactly what happens in a phenomenon called frame dragging. When black holes spin, they literally drag the fabric of spacetime around with them, creating a whirlpool in the structure of reality itself. Nothing can remain stationary near a spinning black hole. Even light gets swept along in the direction of the rotation. This effect creates a region called the ergosphere, where spacetime itself is being dragged faster than light speed. Inside this zone, standing still becomes impossible. You're forced to move in the direction of the black hole's spin whether you want to or not. It's like being caught in a cosmic river current that flows through the dimensions of space and time simultaneously. This dragging effect has been measured around Earth using sensitive gyroscopes, proving that our planet also drags spacetime, though by an almost immeasurably small amount. Around a massive spinning black hole, the effect becomes extreme, turning the vicinity into a cosmic washing machine where spacetime itself churns and swirls. 11. Neutron star material defies comprehension. Imagine taking Mount Everest, all 60 trillion kilograms of rock, ice, and atmosphere, and compressing it into a sugar cube. That's the density of neutron star material, where atomic structure collapses under gravity so intense it overwhelms the electromagnetic forces that keep ordinary matter intact. In this extreme environment, protons and electrons are crushed together to form neutrons, creating matter so dense that physics approaches its breaking point. A neutron star packs 1.5 times the mass of our Sun into a sphere only 12 miles across, small enough to fit inside Manhattan. The surface of a neutron star would appear smooth to within millimeters despite gravitational forces that would instantly obliterate anything made of normal matter. If you could somehow transport a teaspoon of neutron star material to Earth, it would weigh about 5 billion tons, more than all the fish in all Earth's oceans combined. This isn't just compressed matter. It's matter in a state that doesn't exist anywhere else in the universe except in the cores of neutron stars and possibly inside black holes. 12. Surface gravity that crushes understanding. Standing on a neutron star would subject you to gravitational forces 100 billion times stronger than Earth's gravity. This isn't just really heavy. It's gravitational force so extreme it transcends human comprehension. Your body weight would instantly increase to 100 billion times normal, meaning a 150-pound person would suddenly weigh 15 trillion tons. The gravitational acceleration is so intense that it would compress your atomic structure, flattening you into a layer just atoms thick before you could even perceive what was happening. Mountains on neutron stars can't exist above a few millimeters tall because gravity immediately flattens any surface irregularities. The escape velocity from a neutron star's surface approaches half the speed of light, 150,000 kilometers per second. If you dropped a marshmallow from 1 meter above the surface, it would hit the ground with the energy of an atomic bomb. Light itself struggles to escape, becoming gravitationally redshifted as it climbs out of the star's gravity well. This is matter and energy pushed to the absolute limits of what's physically possible in our universe, a realm where conventional physics begins to break down. 13. The fastest spinner completes 716 rotations per second. In the constellation Tirzan, A neutron star designated PSR J1748-2446 adds spins so fast it defies belief. 716 complete rotations every single second. This stellar remnant rotates faster than a kitchen blender, despite being 12 miles across and containing more mass than our Sun. At the equator, material moves at 70,000 kilometers per second, nearly 1/4 the speed of light. The centrifugal force trying to tear the star apart is almost incomprehensible, yet the neutron star holds together through sheer gravitational force. If Earth spun this fast, a day would last 0.0014 seconds, and everything on the surface would be flung into space at tremendous velocities. The precision of this rotation is staggering, more accurate than atomic clocks. This pulsar maintains its incredible spin rate with such consistency that astronomers use it as a cosmic timekeeper. The energy required to spin such a massive object at this rate comes from the star's magnetic field interactions with surrounding matter. As material falls onto the neutron star, it transfers angular momentum, gradually spinning up this cosmic lighthouse until it reaches rotational speeds that seem to violate common sense. 14. Pulsar precision rivals atomic clocks. Deep in space, cosmic lighthouses called pulsars keep time with precision that rivals humanity's most sophisticated atomic clocks. These rapidly spinning neutron stars emit beams of radiation from their magnetic poles, and as they rotate, these beams sweep across space like lighthouse beams across the ocean. When these beams point toward Earth, we detect them as incredibly regular pulses. Some millisecond pulsars are so precise that their timing stability rivals the best atomic clocks humans have ever built. The Crab pulsar, for instance, has been spinning at nearly the same rate for over 1,000 years, varying by only a few parts in a billion. This consistency is so reliable that astronomers use arrays of pulsars as cosmic GPS systems to detect gravitational waves. When gravitational waves pass through the galaxy, they slightly alter the timing of pulsar signals reaching Earth, creating a detectable pattern across multiple pulsars. These natural cosmic chronometers are essentially 12-mile-wide atomic clocks scattered throughout the galaxy, each one maintaining near-perfect time for millions of years. They represent the universe's most stable timekeeping mechanisms, far more reliable than any human technology. 15. Magnetic fields that bend reality. Magnetars possess magnetic fields so powerful they warp the very structure of reality itself. With field strengths reaching 100 billion Tesla, a quadrillion times stronger than Earth's magnetic field, these neutron stars create conditions where the normal rules of physics break down. In such extreme magnetic environments, the vacuum of space itself becomes birefringent, meaning light waves traveling in different directions experience different refractive properties. Photons can split into two separate particles when passing through these fields. Atoms are compressed into needle-thin cylinders, with electron clouds stretched into impossible shapes. The magnetic pressure in these fields exceeds the pressure inside atomic nuclei. If you could somehow place a magnetar halfway between Earth and the Moon, its magnetic field would erase every credit card, hard drive, and electronic device on our planet. The field is so intense that it affects the polarization of light, making the quantum vacuum behave like a crystal. Virtual particle pairs are constantly created and destroyed in these magnetic storms, turning empty space into a seething foam of quantum activity. These are the most magnetic objects in the known universe, where electromagnetism becomes a dominant force capable of overwhelming all other physical interactions. 16. Starquakes that outshine the Sun. On December 27, 2004, the magnetar SGR 1806-20 experienced a starquake that redefined our understanding of cosmic violence. In 1/10 of a second, this neutron star released more energy than our Sun has produced in the last 100,000 years. The star's crust, made of crystallized atomic nuclei, cracked and shifted by mere millimeters, but that tiny movement unleashed a gamma-ray burst so intense it temporarily blinded X-ray satellites across the solar system. The explosion was so powerful that it measurably affected Earth's upper atmosphere from 50,000 light-years away, ionizing particles in our magnetosphere and disrupting radio communications. To put this in perspective, if SGR 1806-20 were located just 10 light-years from Earth, closer than the nearest star, this single burst would have delivered more energy to our planet than we receive from the Sun in an entire year. The starquake fractured the neutron star's surface with the energy equivalent of a magnitude 23 earthquake, a scale so far beyond anything possible on Earth that it defies comparison. This wasn't stellar death. It was stellar violence of a magnitude that makes supernovas seem gentle. 17. Magnetic energy exceeds matter itself. In the realm of magnetars, magnetic fields become so intense that they transcend their role as mere forces and become a form of matter themselves. The energy density stored in a magnetar's magnetic field actually exceeds the mass energy density of ordinary matter, creating a situation where magnetism becomes the dominant component of reality. According to Einstein's E=mc², energy and mass are interchangeable, and in magnetar fields, magnetic energy reaches levels where it begins to gravitationally affect space-time itself. The magnetic pressure inside these fields is greater than the pressure that prevents atoms from collapsing, meaning magnetic forces literally outweigh nuclear forces. This creates exotic conditions where photons moving through the field can spontaneously split into electron-positron pairs, and virtual particles pop into existence from the quantum vacuum. The magnetic field lines become so twisted and compressed that they store enormous amounts of energy, like cosmic rubber bands stretched to their breaking point. When these fields suddenly reorganize during a starquake, they release energy that makes nuclear explosions seem insignificant. In this realm, magnetism isn't just a force, it's the primary constituent of reality, more fundamental than matter itself. 18. The brightest explosion since the Big Bang. On October 9, 2022, Earth was bathed in the afterglow of the most powerful explosion ever recorded in the modern universe. Gamma ray burst GRB 221009A, nicknamed the brightest of all time, erupted from a collapsing star 7.5 billion light-years away with such ferocity that it was visible to the naked eye despite its incredible distance. In just a few seconds, this cosmic detonation released more energy than our sun will produce during its entire 10 billion-year lifetime. The burst was so bright it saturated gamma-ray detectors across the solar system and created a detectable aurora in Earth's upper atmosphere. Astronomers estimate this explosion was visible from 10 billion light-years away, meaning alien civilizations in distant galaxies could have easily spotted it with basic telescopes. The gamma-ray beam was so tightly focused that Earth happened to be directly in its path, giving us a front-row seat to the universe's most spectacular light show. This wasn't just a star exploding. This was matter and energy pushed to the absolute limits of physics, creating a flash of light brighter than trillions of galaxies combined. 19. Potential planet sterilizers. Gamma-ray bursts represent the universe's most efficient extinction mechanisms, capable of sterilizing entire planets from thousands of light-years away. When a massive star collapses into a black hole, it can emit focused beams of gamma radiation with the power of quadrillions of nuclear weapons. If such a burst occurred within our galaxy and pointed directly at Earth, the consequences would be catastrophic beyond imagination. The initial gamma-ray flash would strip away our ozone layer in minutes, exposing all life to lethal ultraviolet radiation from the sun. The burst would trigger massive climate change, destroy the food chain, and potentially cause a mass extinction event. Some scientists hypothesize that the late Ordovician mass extinction 450 million years ago, which eliminated 85% of marine species, might have been caused by a gamma-ray burst from a distant star. The scary reality is that we wouldn't see it coming. Gamma rays travel at light speed, so the deadly radiation would arrive at the same time as the light announcing the explosion. Fortunately, no known gamma-ray burst candidates in our galaxy are currently pointed toward Earth, but the universe contains millions of such cosmic guns. 20. Energy equivalent to converting the sun. The gamma-ray burst GRB 971214 demonstrated the universe's capacity for destruction on a scale that challenges human comprehension. The energy released during this cosmic explosion was equivalent to converting the entire mass of our sun into pure energy according to Einstein's E=mc² equation. Imagine every single hydrogen atom in the sun, roughly 10 to the power of 57 atoms, being transformed into photons and exotic particles. For comparison, nuclear fusion in the sun's core converts only 0.7% of hydrogen's mass into energy, but this gamma-ray burst achieved 100% conversion efficiency. The explosion was so energetic that for the brief duration of the burst, it outshone the entire rest of the observable universe. This single event, lasting only seconds, produced more energy than our sun will generate during its entire multi-billion-year existence. The mechanism behind such incredible energy release involves matter falling into a newly formed black hole, where gravitational forces accelerate particles to near-light speed and magnetic fields focus the resulting energy into narrow beams. It's the universe's most efficient engine of destruction, capable of releasing the mass energy of an entire star in moments that feel instantaneous on cosmic scales. 21. The universe is 95% unknown. Humanity faces a humbling cosmic truth. We have absolutely no idea what 95% of the universe actually is. Everything we can see, touch, and directly detect, every star, planet, galaxy, nebula, and particle of ordinary matter, comprises only 5% of everything that exists. The remaining 95% consists of dark matter, 27%, and dark energy, 68%. Both completely invisible and detectable only through their gravitational effects. Dark matter doesn't interact with light, making it literally invisible, yet it outweighs normal matter by more than 5-to-1. Dark energy is even more mysterious, a force that's accelerating the expansion of the universe itself, pushing galaxies apart at an ever-increasing rate. Scientists have been searching for dark matter particles for decades using the most sensitive detectors ever built. Yet these substances remain as elusive as ghosts. We can map dark matter's presence through gravitational lensing and track dark energy through cosmic expansion, but we cannot directly observe either. It's as if we're trying to understand a symphony while being deaf to 95% of the orchestra. The universe is fundamentally composed of phenomena that exist beyond our current ability to perceive or comprehend. 22. Dark matter's invisible dominance. Across the cosmos, an invisible army of particles outweighs everything we can see by a crushing margin of 6-to-1. Dark matter doesn't emit, absorb, or reflect light, making it completely transparent to our telescopes, yet its gravitational fingerprints are everywhere. In small dwarf galaxies, this invisible matter can outmass ordinary matter by factors of hundreds or even thousands, creating stellar systems that are essentially dark matter with a few stars sprinkled throughout. Galaxy clusters, the largest bound structures in the universe, are held together not by the stars we see, but by vast halos of dark matter extending far beyond the visible boundaries. When galaxies collide, dark matter passes right through itself like cosmic ghosts, while ordinary matter crashes and burns in spectacular displays. The Bullet Cluster, formed by two galaxy clusters colliding at millions of miles per hour, shows dark matter cleanly separated from normal matter, proving these invisible particles interact only through gravity. Without dark matter's scaffolding, galaxies couldn't have formed, stars wouldn't exist, and life itself would be impossible. We are cosmic minorities living in a universe dominated by substances we cannot see, touch, or understand. 23. Matter is fundamentally hollow. The solid reality you experience every day is an elaborate illusion constructed by electromagnetic forces. If you could shrink down to explore an atom's interior, you discover a landscape dominated by emptiness. Picture an atomic nucleus as a marble sitting in the center of a baseball stadium. The nearest electron would be orbiting somewhere in the cheap seats half a mile away. Between the nucleus and electrons lies virtually nothing but empty space. Matter is 99.99999999999% hollow, a decimal point followed by 13 zeros before you reach the first significant digit. The solid chair you're sitting on, the ground beneath your feet, even your own body, all are composed of atoms that are essentially tiny solar systems with vast empty regions between components. What creates the illusion of solidity are electromagnetic forces between electron clouds, the same forces that prevent two magnets from occupying the same space. When you touch a table, you're not actually making contact with its atoms. You're feeling the electromagnetic repulsion between electron clouds. The universe is fundamentally hollow, held together by invisible forces, yet this emptiness gives rise to all the complexity and beauty of existence. 24. The observable universe's true size. The observable universe is much larger than you might expect from its 13.8 billion-year age. While light from the most distant objects has been traveling toward us for 13.8 billion years, the universe has been expanding during that entire journey, stretching space itself and carrying those distant objects much farther away. Today, the edge of the observable universe lies 46.5 billion light-years from Earth in every direction, creating a cosmic sphere 93 billion light-years in diameter. Objects that emitted light when the universe was only 380,000 years old are now receding from us faster than light speed due to cosmic expansion. This creates a cosmic horizon beyond which we can never see, no matter how long we wait or how powerful our telescopes become. The galaxies at this edge appear as they were in the cosmic dawn, redshifted to infrared wavelengths by their incredible recession velocities. Beyond this horizon lies the unknowable, more universe that will forever remain invisible to us. The observable universe is just a bubble of visibility in what may be an infinite cosmos, a cosmic fishbowl beyond which the true scale of reality remains hidden. 25. Galaxy abundance beyond comprehension. The observable universe contains approximately 2 trillion galaxies, a number so vast it defies human comprehension. To put this in perspective, there are 285 galaxies for every single person who has ever lived on Earth. Each galaxy contains billions or trillions of stars, and many of those stars have planetary systems. The Milky Way alone has an estimated 100 to 400 billion stars, yet it's just one galaxy among trillions. Until 2016, astronomers thought there were only 100 to 200 billion galaxies, but improved observations revealed they were off by an entire order of magnitude. Using the Hubble Space Telescope's deep-field images, researchers counted galaxies in tiny patches of seemingly empty sky, then extrapolated to the entire observable universe. The results were staggering. Every patch of sky, no matter how dark it appears, contains thousands of distant galaxies. If you held a grain of sand at arm's length, it would cover a region of sky containing over 10,000 galaxies. Each point of light represents billions of years of cosmic evolution, stellar birth and death, and potentially countless worlds. The universe is not just vast, it's populated beyond imagination. 26. Inflation's incredible expansion. In the first tiny fraction of a second after the Big Bang, the universe underwent a period of expansion so rapid and extreme it challenges comprehension. During cosmic inflation, space itself expanded by more than 60 e-folds, mathematical terminology that translates to a factor of approximately 10 followed by 26 zeros. A region smaller than a proton grew to the size of a grapefruit in about 10 to the power of -32 seconds, a time interval so brief that light could travel only a tiny fraction of a proton's width. This wasn't matter moving through space. This was space itself expanding faster than light speed, carrying matter along for the ride. The expansion was so violent that quantum fluctuations were stretched from subatomic scales to cosmic proportions, creating the slight density variations that would eventually become galaxies, stars, and planets. Without inflation, the universe would have collapsed back on itself almost immediately or expanded so rapidly that matter could never clump together. Inflation solved several cosmic mysteries. Why the universe appears flat, why it's nearly uniform in temperature, and why we don't see exotic relics like magnetic monopoles. In less than a billionth of a trillionth of a trillionth of a second, inflation set the stage for everything that would follow. 27. The flatness miracle. The universe exists in a state of cosmic perfection so precise it seems miraculous. Cosmologists measure the universe's geometry using a parameter called omega, the ratio of actual density to critical density. If omega is greater than 1, the universe curves back on itself like a sphere and eventually collapses. If omega is less than 1, space curves like a saddle and expands forever with galaxies flying apart. Our universe has omega incredibly close to exactly 1, making space geometrically flat to within 1% precision. This seems like a remarkable coincidence until you realize how precisely the early universe needed to be fine-tuned to achieve this flatness. Without cosmic inflation, the initial conditions would have required adjustment to 1 part in 10 to the power of 62, a number so large that if you wrote it out, the zeros would fill several books. It's like balancing a pencil on its point for 13.8 billion years. Inflation naturally explains this flatness by stretching any initial curvature smooth, like blowing up a balloon until its surface appears flat to any observer on it. Without this cosmic flatness, galaxies couldn't form, stars wouldn't ignite, and life could never emerge. We exist because the universe achieved geometric perfection. 28. Quantum fluctuations became galaxies. The largest structures in the universe, galaxy clusters spanning hundreds of millions of light-years, began as quantum fluctuations smaller than atomic nuclei. During cosmic inflation, the Heisenberg uncertainty principle created tiny variations in energy density at quantum scales. These fluctuations were initially variations of only about 0.003%, barely detectable ripples in the fabric of spacetime. But inflation stretched these quantum hiccups across cosmic distances, preserving their patterns while amplifying their scale by factors of 10 to the power of 26 or more. When inflation ended, these stretched quantum fluctuations became the seeds for all cosmic structure. Regions slightly denser than average began attracting matter through gravity, slowly growing over millions of years into the first stars, galaxies, and galaxy clusters. The cosmic microwave background preserves the imprint of these primordial fluctuations as tiny temperature variations across the sky. Remarkably, computer simulations can start with these quantum scale variations and accurately reproduce the cosmic web of galaxies we observe today. Every star system, every planet, every living creature exists because of quantum uncertainty, proof that the smallest scale physics governs the largest scale structures. The universe is quantum mechanical all the way up. 29. Dark energy began dominating 5 billion years ago. For the first 8.8 billion years of cosmic history, gravity ruled the universe. Dark matter and ordinary matter worked together to slow cosmic expansion, pulling galaxies closer together through gravitational attraction. Then, around 5 billion years ago, something fundamental changed. Dark energy, a mysterious force inherent in space itself, began to dominate cosmic evolution. Unlike matter and energy that dilute as the universe expands, dark energy maintains constant density. As space grows larger, more dark energy appears, creating an accelerating feedback loop. Dark energy has negative pressure equal to exactly -1 times its energy density, causing space itself to push apart rather than pull together. This cosmic competition between gravity and dark energy determined the universe's fate. For the first half of cosmic history, gravity won and expansion slowed down. But as galaxies moved apart and dark energy accumulated, acceleration began. The universe transitioned from decelerating expansion to accelerating expansion around the time our solar system was forming. Now, dark energy drives galaxies apart at ever-increasing speeds, eventually leading to a cosmic future where every galaxy beyond our local group disappears beyond the cosmic horizon, leaving future astronomers in a lonely, dark cosmos. 30. The worst prediction in physics. Quantum field theory produces what scientists call the worst prediction in the history of physics. An error so monumentally wrong it defies explanation. When physicists calculate how much energy should exist in empty space due to quantum fluctuations, they get an answer that's 10 to the power of 120 times larger than what we actually observe. This is a 1 followed by 120 zeros, a number so vast that if you wrote it in normal-sized text, it would stretch from Earth to the edge of the observable universe and back again millions of times. If the quantum calculation were correct, the vacuum energy would be so enormous that space itself would collapse into black holes instantly, making atoms, stars, planets, and life completely impossible. Yet somehow, the universe exists with this impossibly fine-tuned value that allows matter to exist and galaxies to form. This represents either the most spectacular failure of theoretical physics or the most incredible cosmic coincidence ever discovered. Some physicists propose that this perfect cancellation points to deeper physics we don't understand, perhaps multiple universes, unknown symmetries, or fundamentally different laws of nature. The fact that we exist to contemplate this problem suggests that the universe operates according to principles far more subtle and mysterious than our current theories can explain. 31. Dark energy might be weakening. Recent observations from multiple independent studies have detected something that could revolutionize our understanding of cosmic fate. Dark energy appears to be evolving and possibly weakening over time. The Dark Energy Survey and the Dark Energy Spectroscopic Instrument, DESI, have found hints that dark energy's strength isn't constant, but may have decreased slightly over cosmic history. This discovery contradicts the standard model of cosmology, which assumes dark energy remains perfectly constant. If dark energy is indeed weakening, the implications are profound. Instead of an endless acceleration leading to a cold, empty cosmos where galaxies disappear beyond the horizon, the universe's expansion might eventually stabilize or even reverse. The cosmic acceleration that began 5 billion years ago might be temporary rather than eternal. Different measurements show varying levels of this effect, creating intense debate among cosmologists. Some data suggests dark energy was stronger in the past and has been gradually declining. If this trend continues, gravity might eventually regain dominance, potentially leading to a big crunch, where the universe collapses back on itself. Alternatively, dark energy might stabilize at a lower level, creating a universe that expands more gently. These observations are still preliminary, but they hint that the cosmic story may be far more complex than we imagined. 32. Venus spins backwards with impossible days. Venus defies every expectation we have about planetary motion. While almost every other planet in the solar system rotates in the same direction they orbit the Sun, Venus spins backwards, a phenomenon called retrograde rotation. On Venus, the Sun rises in the west and sets in the east, the exact opposite of Earth. Even more bizarre, Venus rotates so slowly that its day is longer than its year. A single Venusian day lasts 243 Earth days, while a Venusian year is only 225 Earth days. This means you could celebrate 2 birthdays before watching the Sun complete one journey across the sky. Scientists believe Venus's backwards rotation resulted from a catastrophic collision with another planet-sized object early in the solar system's history, or from gravitational interactions that gradually reversed its spin over millions of years. The slow rotation also means Venus lacks a global magnetic field generated by a spinning molten core, leaving the planet defenseless against solar wind. This backward, sluggish rotation contributes to Venus's hellish atmospheric conditions by preventing the heat-distributing winds that moderate temperatures on other planets. Venus reminds us that planetary evolution can take dramatically different paths, creating worlds that operate by alien rules. 33. Atmospheric winds outpace planetary rotation. Venus presents one of the solar system's most baffling meteorological mysteries: atmospheric winds that circle the planet 50 times faster than the planet itself rotates. While Venus takes 243 Earth days to complete one rotation, hurricane-force winds in its upper atmosphere race around the entire planet in just 4 Earth days, reaching speeds of 224 miles per hour. This creates a phenomenon called superrotation, where the atmosphere spins independently of the solid planet below, like a cosmic hurricane that engulfs an entire world. The mechanism driving these extreme winds remains a mystery that has puzzled planetary scientists for decades. Despite receiving very little energy from the distant Sun, Venus somehow maintains these constant global winds that would strip the roofs off buildings if they existed on Earth. The winds are strongest at altitudes of 35 to 43 miles above the surface, in the planet's thick sulfuric acid cloud layer. Lower in the atmosphere, near Venus's crushing surface, winds slow to just a few miles per hour due to friction with the ground. This creates a bizarre 2-layer wind system where the upper atmosphere races around the planet while the lower atmosphere barely moves. A meteorological phenomenon unlike anything seen elsewhere in the solar system. 34. Surface conditions from hell. Venus represents the most hostile planetary environment in the solar system, with surface conditions that exceed the imagination of science fiction writers. The surface temperature reaches 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead, zinc, and tin. This crushing heat is maintained by a runaway greenhouse effect created by an atmosphere that's 96% carbon dioxide, trapping solar energy like a planetary oven. The atmospheric pressure at Venus's surface is 90 times greater than Earth's, equivalent to the crushing pressure 3,000 feet underwater in Earth's oceans. If you could somehow survive the heat, the pressure would instantly crush you like an empty soda can. The atmosphere contains clouds of concentrated sulfuric acid that create acid rain so corrosive it would dissolve metal, though this rain never reaches the surface because it evaporates in the intense heat miles above the ground. Lightning crackles constantly through these acid clouds with strikes more frequent and powerful than those on Earth. Soviet landing probes that reached Venus's surface in the 1970s survived for only minutes to hours before the extreme conditions destroyed their electronics and crushed their hulls. Venus proves that small changes in planetary evolution can create dramatically different worlds. Our sister planet became a vision of hell. 35. Jupiter's Great Red Spot dwarfs Earth. Jupiter's Great Red Spot is a hurricane that has been raging continuously for at least 400 years, longer than the United States has existed as a nation. This cosmic storm is so enormous that Earth could fit inside it 1.3 times, with room to spare. Unlike hurricanes on Earth that dissipate when they make landfall or encounter cooler water, Jupiter's Great Red Spot has no solid surface to disrupt its circulation, allowing it to persist for centuries. Recent data from NASA's Juno mission revealed that this storm extends an astounding 200 miles deep into Jupiter's atmosphere, 100 times deeper than Earth's deepest ocean trenches. The storm's winds reach speeds of 270 miles per hour, faster than the strongest hurricanes ever recorded on Earth. What's even more remarkable is that the Great Red Spot has been shrinking over the past century. Historical observations show it was once large enough to fit 3 Earths side by side. Despite its diminishing size, it remains one of the most powerful and long-lasting weather systems in the solar system. The spot's distinctive red color comes from complex chemical reactions in Jupiter's upper atmosphere, possibly involving phosphorus or sulfur compounds mixed with organic molecules created by lightning. This ancient storm is literally older than telescopic astronomy itself.
36. Jupiter's Impossible Geometric Storm.
Saturn's North Pole hosts one of the most geometrically perfect and mysterious phenomena in the solar system, a massive hexagonal storm that spans 20,000 miles across, larger than 2 Earth diameters. Each side of this cosmic hexagon measures approximately 9,000 miles long, creating a geometric shape so precise it looks artificial. The hexagon rotates as a rigid structure every 10 hours and 39 minutes, maintaining its 6-sided shape with mathematical precision that has persisted for over 40 years of continuous observation. Inside this hexagonal boundary, winds rage at speeds up to 200 miles per hour, while the hexagon's walls act like cosmic guardrails containing the storm. The phenomenon defies explanation because nature rarely produces such perfect geometric shapes, especially on planetary scales. Laboratory experiments have recreated similar hexagonal patterns in rotating fluids under specific conditions, suggesting the hexagon results from complex interactions between Saturn's rotation and atmospheric dynamics. The storm sits at Saturn's North Pole like a cosmic flower, with a smaller, circular storm at its center resembling the eye of a hurricane. No other planet displays anything similar, making Saturn's hexagon one of the solar system's most unique and visually striking features. It's a reminder that planetary atmospheres can create phenomena that seem designed by alien mathematicians. 37. Jupiter's core is fuzzy. NASA's Juno mission revolutionized our understanding of Jupiter by discovering that the gas giant doesn't have a solid core like Earth. Instead, Jupiter's center is fuzzy, a dilute mixture of rock, metals, hydrogen, and helium that extends across nearly half the planet's diameter. This discovery overturned decades of planetary formation theory, which predicted Jupiter should have a compact, solid core surrounded by distinct layers of metallic hydrogen and gaseous atmosphere. The fuzzy core suggests Jupiter's formation was far more chaotic and violent than previously imagined. Scientists now believe that during Jupiter's early formation, it may have collided with planetary embryos or experienced massive impacts that mixed its core material with the surrounding atmosphere. Alternatively, the core might have dissolved over billions of years due to convective mixing processes that gradually dispersed rock and metal throughout the interior. This fuzzy structure explains why Juno's gravity measurements didn't detect a sharp boundary between core and mantle. Instead, the spacecraft found a gradual transition from rocky material to hydrogen-helium mixture, creating a planetary interior unlike anything in our theoretical models. Jupiter's fuzzy core forces us to reconsider how gas giants form and evolve, suggesting planetary formation is messier and more complex than our tidy models suggested. 38. Jupiter's secret 3,000-mile jet stream. In 2025, the James Webb Space Telescope discovered a previously unknown jet stream racing across Jupiter at 320 miles per hour, over 3,000 miles wide and somehow invisible to decades of previous observations. This massive atmospheric river flows above Jupiter's famous cloud bands, at altitudes where temperatures plummet to -100 degrees Fahrenheit. The jet stream is so high in Jupiter's atmosphere that it exists in a realm where very few clouds form, making it nearly transparent to visible light telescopes like Hubble. Only Webb's infrared vision could detect the temperature differences that reveal this hidden atmospheric feature. The discovery raises puzzling questions about Jupiter's atmospheric dynamics. How can such a massive air current exist without being detected for centuries of telescopic observation? The jet stream appears to be a completely separate atmospheric layer above the well-known cloud bands that define Jupiter's appearance. Its speed of 320 miles per hour makes it twice as fast as the jet streams on Earth, despite Jupiter receiving 25 times less energy from the Sun. This hidden river of air demonstrates that even our neighboring planets still harbor major undiscovered features. Jupiter's atmosphere is apparently far more complex and layered than anyone suspected, with entire wind systems operating in atmospheric regions we've barely begun to explore. 39. Saturn would float in water. Despite being the second largest planet in the solar system, Saturn possesses such low density that it would float if you could find an ocean large enough to contain it. Saturn's average density is only 0.687 grams per cubic centimeter, compared to water's density of 1 gram per cubic centimeter. This remarkable property results from Saturn's composition. It's made primarily of hydrogen and helium, the lightest elements in the universe. While Saturn is 95 times more massive than Earth, its volume is so enormous that its overall density remains less than liquid water. The planet's low density creates other unusual characteristics. Saturn is the most oblate, flattened planet in the solar system, with a polar diameter that's 10% smaller than its equatorial diameter due to rapid rotation and weak gravitational cohesion. If Saturn did float in a cosmic ocean, about 30% of the planet would remain above the waterline, like a giant cosmic cork bobbing in an infinite sea. This low density also means that Saturn's gravity at its visible cloud tops is similar to Earth's surface gravity, despite the planet's enormous mass. Saturn's ethereal composition makes it the least dense planet in our solar system, a giant made of materials lighter than air, held together only by its own vast gravitational field. 40. Enceladus shoots 200-mile geysers. Saturn's small moon Enceladus, only 310 miles in diameter, produces one of the solar system's most spectacular displays. Massive geysers of water ice that shoot 200 miles into space from its south pole. These cosmic fountains erupt from 4 parallel fractures nicknamed tiger stripes that cut across Enceladus's southern hemisphere. The geysers blast water vapor, ice particles, and organic compounds at speeds exceeding 800 miles per hour, creating a constant spray that feeds Saturn's E-ring with fresh ice particles. Remarkably, Enceladus reflects nearly 100% of the sunlight that hits it, making it the most reflective body in the solar system, more mirror-like than fresh snow. The energy driving these geysers comes from tidal heating caused by Saturn's gravity, which flexes and stretches the moon's interior as it orbits. This tidal massage keeps Enceladus's subsurface ocean liquid despite the moon's great distance from the sun. The Cassini spacecraft flew through these geysers multiple times, directly sampling their composition and discovering organic molecules that could be building blocks of life. The geysers provide a direct window into Enceladus's hidden ocean, which may contain twice as much water as all Earth's oceans combined. These 200-mile-high fountains make Enceladus one of the most promising places to search for extraterrestrial life. 41. Titan's methane weather system. Saturn's largest moon, Titan, operates the only complete weather system in the solar system besides Earth's. But instead of water, everything is made of methane. At Titan's surface temperature of -290 degrees Fahrenheit, methane behaves exactly like water does on Earth, existing as liquid in lakes and seas, vapor in the atmosphere, and solid in clouds and precipitation. Titan has a complete hydrological cycle with methane clouds that produce methane rain, which flows down methane rivers into methane lakes and seas. The Moon experiences seasonal weather patterns as Saturn orbits the Sun, with methane storms moving between hemispheres and lake levels rising and falling with the seasons. Titan's largest body of liquid, Kraken Mare, is larger than the Caspian Sea and contains more hydrocarbons than all known oil and natural gas reserves on Earth. The Moon's thick nitrogen atmosphere creates weather phenomena remarkably similar to Earth's. Cloud formation, precipitation, erosion, and even dust storms composed of hydrocarbon particles. Titan's surface features river deltas, sand dunes made of organic compounds, and seasonal rainfall that carves channels in the landscape. This alien world demonstrates that familiar weather processes can operate with completely different chemistry, creating a bizarre mirror image of Earth where liquid methane replaces water in every aspect of climate and geology. 42. Mars has 12-mile-high dust devils. Mars regularly produces dust devils that tower 12 miles into the thin Martian atmosphere, high enough to reach the stratosphere if they occurred on Earth. These towering vortices of dust and wind can be seen from orbiting spacecraft as dark shadows racing across the Martian landscape at speeds up to 70 miles per hour. Unlike Earth's dust devils, which rarely exceed a few hundred feet in height, Martian dust devils benefit from the planet's low atmospheric pressure and reduced gravity, allowing them to grow to enormous proportions. The largest dust devils on Mars can be half a mile wide at their base and persist for hours as they traverse the rocky terrain. In 2018, a global dust storm enveloped the entire planet for several months, creating a planetary dust cloud so thick it blocked sunlight from reaching the surface and effectively ended NASA's Opportunity rover mission after 15 years of operation. These dust storms can develop with startling speed, growing from localized whirlwinds to planet-spanning tempests in just days. The fine Martian dust is electrostatically charged and clings to everything, creating hazards for both robotic and future human missions. Despite Mars's thin atmosphere, less than 1% of Earth's pressure, these dust devils pack enough energy to sandblast rocks, erode landscape features, and pose serious challenges for any surface operations on the red planet. 43. Pure sulfur crystals that shouldn't exist. In 2024, NASA's Curiosity rover made an accidental discovery that has baffled planetary scientists. Fields of pure elemental sulfur crystals scattered across the Martian surface like cosmic gems. When the rover accidentally crushed a seemingly ordinary rock while driving through the Geddes Vallis Channel, bright yellow sulfur crystals were revealed inside, marking the first discovery of pure elemental sulfur on Mars. According to everything scientists know about Martian geology and chemistry, these crystals shouldn't be there. Sulfur on Mars has always been found in combination with other elements, forming sulfates and other mineral compounds, but never in its pure elemental form. Pure sulfur requires very specific conditions to form and remain stable, conditions that don't exist in Mars's current environment. The discovery raises fundamental questions about Martian geological processes. How did these crystals form? How long have they existed? And what does their presence reveal about Mars's hidden chemical history? The crystals suggest unknown geological processes are occurring on Mars, possibly involving subsurface chemistry or ancient environmental conditions very different from what scientists expected. This accidental discovery demonstrates that Mars continues to surprise us with geological phenomena that challenge our understanding of planetary formation and evolution. Even after decades of exploration, the red planet keeps revealing secrets that force us to reconsider everything we thought we knew.
44. Mars Impossible Canyon.
Valles Marineris, the Grand Canyon of Mars, is a geological feature so massive it defies comparison to anything on Earth. This enormous canyon system stretches 2,500 miles across the Martian surface, long enough to span the entire continental United States from New York to Los Angeles. The canyon reaches depths of up to 4 miles and widths of 120 miles, making it over 10 times longer, 5 times deeper, and 20 times wider than the Grand Canyon. If Valles Marineris existed on Earth, it would stretch from the Atlantic Ocean to the Pacific Ocean, fundamentally altering our planet's geography and climate. The canyon's formation remains partially mysterious, though scientists believe it resulted from a combination of geological processes including massive volcanic activity, tectonic stretching, and catastrophic flooding. The canyon system connects to ancient river channels that suggest massive floods once carved through the Martian landscape, carrying volumes of water that would dwarf any floods in Earth's history. Some sections of Valles Marineris show evidence of landslides that moved billions of tons of rock, creating debris piles the size of small mountains. The canyon's sheer scale demonstrates that Mars once experienced geological activity far more violent and dramatic than anything occurring on the planet today. It's a scar across an entire world, preserving evidence of ancient catastrophes that reshaped planetary geography. 45. Uranus rolls like a barrel. Uranus is the solar system's cosmic oddball, tilted 98 degrees on its side so that it essentially rolls around the sun like a barrel instead of spinning like a top. This extreme axial tilt means that Uranus's north and south poles alternately point toward the sun during its 84-year orbit, creating the most extreme seasons in the solar system. Each pole experiences 42 years of continuous sunlight followed by 42 years of total darkness. During Uranus's solstices, one hemisphere bakes in constant sunlight while the other freezes in permanent winter. This bizarre orientation probably resulted from a massive collision with an Earth-sized object early in the solar system's history, knocking Uranus over on its side. The impact was so violent it not only tilted the planet but also disrupted its magnetic field, which is tilted 59 degrees from the planet's rotational axis and doesn't even pass through the planet's center. Uranus's extreme tilt affects its weather patterns, magnetic field behavior, and the orbits of its moons, which circle the planet like a Ferris wheel rather than a merry-go-round. When Voyager 2 visited Uranus in 1986, one pole was pointing almost directly at the sun, making the planet appear unusually calm and featureless. As Uranus continues its ponderous orbit, different regions are slowly emerging from decades of darkness into sunlight, potentially triggering dramatic atmospheric changes.
46. Neptunès impossible wind.
Neptune harbors one of the solar system's greatest mysteries: winds that reach 1,500 miles per hour, despite the planet receiving 1,000 times less solar energy than Earth. These supersonic winds are nearly twice the speed of sound and represent the fastest atmospheric motion detected anywhere in the solar system. The puzzle deepens when you consider that wind energy must come from somewhere, yet Neptune orbits so far from the sun that it receives only 1/1000th of the solar energy that drives Earth's weather. The planet is so distant that sunlight is 900 times dimmer than on Earth, yet somehow Neptune maintains winds faster than the most powerful hurricanes ever recorded on our planet. Scientists believe Neptune's extreme winds are powered by internal heat rather than solar energy. The planet radiates 2.6 times more energy than it receives from the sun, suggesting it has a powerful internal heat source, possibly left over from its formation 4.5 billion years ago or generated by radioactive decay in its core. This internal heat drives convection currents that accelerate atmospheric gases to incredible velocities. Neptune's winds also show strange temporal behavior, with wind speeds varying dramatically over timescales of months to years. The planet's extreme winds demonstrate that atmospheric dynamics can operate in ways completely different from Earth's solar-powered weather systems, powered by mysterious internal energy sources that remain poorly understood. 47. All planets fit between Earth and Moon. The space between Earth and the Moon seems vast, but it's actually just large enough to fit all the planets in our solar system lined up in a row. The average distance to the Moon is 238,855 miles, while the combined diameters of Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune total about 235,000 miles. Even if you include Pluto for good measure, all 8 planets plus the dwarf planet would fit in the Earth-Moon gap with only about 3,000 miles to spare, roughly the distance from New York to Los Angeles. This surprising fact illustrates just how much empty space dominates our solar system. The Moon appears large in our sky only because it's relatively close. In reality, it's quite small compared to the gas giants. Jupiter alone, with a diameter of 86,881 miles, takes up more than 1/3 of the Earth-Moon distance. Saturn, at 72,367 miles across, fills another large portion. The remaining rocky planets are tiny by comparison. This cosmic coincidence helps visualize the true scale of our local neighborhood in space. It also demonstrates why the Moon's distance has been crucial for life on Earth, close enough to stabilize our planet's axial tilt and create tides, but far enough away to allow the complex orbital dynamics that regulate our climate over geological timescales. 48. The moon is moving away. Every night you look up at the moon, it's slightly farther away than it was the night before. The moon is gradually spiraling away from Earth at about 1.5 inches per year, roughly the same rate your fingernails grow. This occurs because tidal forces between Earth and Moon gradually transfer rotational energy from our planet to the Moon's orbit, causing it to slowly recede. Over the Moon's 4.5 billion-year history, it has migrated from an initial distance of about 15,000 miles to its current average distance of 238,855 miles. This migration has profound consequences for Earth's future. As the Moon moves away, it appears smaller in our sky, and total solar eclipses become less likely and eventually impossible. In about 600 million years, the Moon will appear too small to completely cover the Sun, ending the cosmic coincidence that makes our perfect solar eclipses possible. The Moon's recession also affects Earth's rotation. As the Moon moves away, days gradually get longer because tidal friction slows Earth's spin. When the Moon first formed, Earth days were only 6 hours long. Eventually, the Moon will become tidally locked to Earth at a distance where both bodies always show the same face to each other. But this won't happen for billions of years, long after the Sun has evolved into a red giant. 49. Lunar formation required impossible collision. The Moon's formation involved one of the most violent events in Earth's early history, a collision with a Mars-sized object called Theia that was so catastrophic it nearly destroyed both worlds. About 4.5 billion years ago, when Earth was still a molten hell's cape, Theia struck our planet at a glancing angle with tremendous force. The impact was so energetic that it vaporized both Earth's crust and Theia entirely, creating a superheated cloud of rock vapor that surrounded our planet like a molten atmosphere. This cosmic catastrophe ejected enormous amounts of material into orbit around Earth, where it gradually coalesced to form the Moon. The collision explains several puzzling features of the Earth-Moon system. Why the Moon has such a large size relative to Earth compared to other planet-Moon systems, why Earth and the Moon have such similar compositions, and why the Moon has a much smaller iron core than expected for its size. The impact also tilted Earth's axis to its current 23.5 degrees, giving us our seasons. Computer simulations show that Theia's collision angle and velocity had to be precisely tuned. Too direct and Earth would have been completely destroyed. Too oblique and insufficient material would have entered orbit to form the Moon. This cosmic accident was essential for life. Without the Moon's gravitational influence to stabilize Earth's axial tilt and drive tidal mixing in ancient oceans, life might never have evolved. 50. Europa has more water than Earth. Jupiter's moon Europa, despite being smaller than Earth's moon, contains more than twice as much water as all of Earth's oceans combined. This water exists as a subsurface ocean beneath Europa's frozen crust, hidden from direct view but detectable through gravitational measurements and surface features. Europa's ocean is estimated to be 60 miles deep, more than 10 times deeper than Earth's deepest ocean trench, the Challenger Deep. The total volume of this hidden ocean reaches approximately 3 billion cubic kilometers, compared to Earth's 1.3 billion cubic kilometers of ocean water. Europa's ocean remains liquid despite the Moon's great distance from the Sun because Jupiter's powerful gravity creates tidal heating, constantly flexing Europa's interior and generating thermal energy. This process keeps the ocean warm enough to remain liquid and may create hydrothermal vents on the ocean floor similar to those that support unique ecosystems in Earth's deep oceans. The ocean is likely in direct contact with Europa's rocky mantle, allowing for complex chemical interactions that could potentially support life. Europa's ice shelf thickness varies from 15 to 25 miles, and recent observations suggest the ocean may occasionally breach the surface through cracks and geysers, providing potential access to this hidden aquatic world. The Moon represents one of the most promising locations in the solar system for finding extraterrestrial life. 51. Europa's ice shell constantly renews. Europa possesses one of the youngest and smoothest surfaces in the solar system, with remarkably few impact craters despite orbiting in a region where asteroid and comet impacts should be common. This pristine surface indicates that Europa's ice shell completely renews itself every 40 to 90 million years through active geological processes driven by the subsurface ocean. The surface shows clear evidence of recent geological activity. Linear cracks called lineae that stretch for hundreds of miles, chaos terrain where the ice has been broken and refrozen in jumbled patterns, and ridge systems that suggest the ice shell is constantly being recycled. These features indicate that warm water or slushy ice regularly erupts from below, resurfacing the moon and erasing ancient craters. Some areas show evidence of recent volcanic-style activity where liquid water may have erupted onto the surface, instantly freezing in the vacuum of space. The constant resurfacing suggests vigorous convection in Europa's ocean, possibly driven by hydrothermal activity on the ocean floor. This dynamic geology makes Europa unique among icy moons. While most frozen worlds preserve ancient crater records for billions of years, Europa's surface is geologically active and constantly changing. The young surface age implies that Europa's ocean has remained active throughout most of solar system history, maintaining conditions that could potentially support life for billions of years. 52. Io spews material into space constantly. Jupiter's moon Io is the most volcanically active body in the solar system, hosting over 400 active volcanoes that create the most dramatic display of geological violence in our cosmic neighborhood. These volcanoes don't just erupt onto Io's surface. They launch material with such force that volcanic plumes reach 190 miles into space, high enough to reach the International Space Station if they occurred on Earth. Io's volcanoes are powered by tidal heating from Jupiter's immense gravity, which constantly flexes the moon's interior like a stress ball, generating enough heat to keep the interior molten. The volcanic activity is so intense that Io spews 1 ton of material into space every single second, creating a donut-shaped cloud of sulfur and oxygen ions around Jupiter called the Io plasma torus. Some volcanic eruptions on Io are so powerful they can be seen with ground-based telescopes on Earth, appearing as bright spots on the moon's surface. Unlike Earth's volcanoes that primarily erupt molten rock, Io's volcanoes spew sulfur and sulfur dioxide, creating a landscape painted in yellows, oranges, and reds that looks like an alien artist's palette. The constant volcanic resurfacing means Io has virtually no impact craters. The surface is so young that it's essentially being repaved faster than meteorites can scar it. Io processes about 100 times more volcanic material per unit area than Earth. 53. Volcanic eruptions reach impossible heights. Due to Io's low gravity, only 18% of Earth's, and its lack of substantial atmosphere, volcanic eruptions achieve heights that would be impossible on any other terrestrial body in the solar system. The tallest volcanic plumes on Io reach 250 miles above the surface, higher than the altitude where the International Space Station orbits Earth. On Earth, volcanic eruptions rarely exceed 20 miles in height due to our planet's stronger gravity and dense atmosphere. But Io's eruptions operate in an environment where physics allows for truly spectacular displays. The volcanic material travels at speeds exceeding 2,300 miles per hour as it's blasted from volcanic vents, creating umbrella-shaped plumes that can be hundreds of miles wide. These eruptions are so violent that they can change Io's appearance dramatically in just days or weeks, with new volcanic features appearing and disappearing faster than astronomers can track them. The Galileo spacecraft observed volcanic plumes that were taller than the distance from New York to Washington, D.C., creating fountains of molten sulfur that freeze solid before falling back to the surface. Some eruptions persist for months, creating sustained fountains of fire visible from millions of miles away. Io's volcanic activity is so intense that the moon completely resurfaces itself every 1,000 years, making it the most geologically active body in the solar system with a landscape that changes faster than Earth's weather patterns. 54. Pluto has blue skies and red snow. When New Horizons flew past Pluto in 2015, it revealed a world far stranger and more beautiful than anyone expected. Despite being a frozen dwarf planet 3 billion miles from the Sun, Pluto has blue skies remarkably similar to Earth's. This blue coloration comes from tiny haze particles in Pluto's thin atmosphere that scatter sunlight, creating the same Rayleigh scattering effect that makes Earth's sky blue. The haze particles are likely complex hydrocarbons called tholins, created when ultraviolet light breaks apart methane molecules in Pluto's atmosphere. Even more bizarre, Pluto experiences red snow, methane precipitation that gives parts of the surface a distinctly reddish tint. The methane snow forms when Pluto's thin atmosphere becomes supersaturated with methane vapor, which then condenses and falls as reddish crystals onto the surface. Pluto also displays active geology despite receiving almost no energy from the sun. The dwarf planet has ice mountains rising 11,000 feet above the surrounding plains, made not of water ice but of nitrogen ice that's hard as rock at Pluto's frigid temperatures. These mountains appear geologically young, suggesting Pluto has been geologically active within the last 100 million years. The combination of blue skies, red snow, and ice mountains creates an alien landscape that's both hauntingly beautiful and scientifically mysterious. 55. Pluto's atmosphere extends remarkably far. Despite Pluto's tiny size, smaller than Earth's moon, its atmosphere extends proportionally much farther into space than Earth's atmosphere relative to planetary size. Pluto's thin atmosphere, composed primarily of nitrogen with traces of methane and carbon monoxide, reaches heights of up to 1,000 miles above the surface. To put this in perspective, if Earth's atmosphere extended proportionally as far as Pluto's, it would reach nearly 25,000 miles into space, far beyond the Moon's orbit. This extended atmosphere exists because Pluto's gravity is so weak that atmospheric gases can escape much more easily than on larger worlds. The atmosphere varies dramatically with Pluto's elliptical 248-year orbit around the Sun. When Pluto is closest to the Sun, increased solar heating sublimes nitrogen ice on the surface, thickening the atmosphere. When Pluto moves farther away, the atmosphere gradually freezes back onto the surface. New Horizons discovered that Pluto's atmosphere is slowly escaping into space at a rate of about 500 tons per hour, insignificant for a planet like Earth, but substantial for a small world like Pluto. The atmospheric escape creates a faint tail of nitrogen gas trailing behind Pluto as it orbits the Sun, making the dwarf planet somewhat comet-like. This extended atmosphere also creates complex haze layers that give Pluto its distinctive blue appearance when backlit by the Sun. 56. HD 189733b. The Glass Rain Death World. Located 63 light-years from Earth, exoplanet HD 189733b presents one of the most nightmarish environments ever discovered. This hot Jupiter appears deceptively beautiful, a brilliant cobalt blue that initially suggested Earth-like characteristics. Instead, this alien world experiences one of the most hostile weather systems imaginable: glass rain falling sideways at 5,400 miles per hour. The planet's stunning blue color doesn't come from oceans, but from clouds laced with silicate glass particles suspended in its 2,300 degrees Fahrenheit atmosphere. These microscopic glass fragments are created by the extreme temperatures and pressures in the planet's upper atmosphere, where silicate compounds condense into tiny shards. The planet is tidally locked to its star, meaning one side permanently faces the star, while the other remains in eternal darkness. This creates temperature differences of over 1,000 degrees Fahrenheit between the day and night sides, driving hurricane-force winds that race around the planet at hypersonic speeds. These winds carry the glass particles horizontally across the planet's surface at velocities that would make the most powerful Category 5 hurricane seem like a gentle breeze. The combination of molten temperatures, crushing atmospheric pressure, and flying glass creates a vision of hell that makes Venus look hospitable by comparison. This world demonstrates that exoplanets can be far more extreme than anything in our solar system. 57. KLT9b, hotter than most stars. KLT9b holds the record as the hottest known exoplanet, with dayside temperatures reaching 7,800 degrees Fahrenheit, hotter than most red dwarf stars and nearly as hot as our Sun's surface. This ultra-hot Jupiter orbits so close to its host star that it completes one orbit in just 1.5 Earth days, locked in a cosmic dance of extreme heat and violence. The planet's dayside is so hot that molecules literally tear apart in the atmosphere, dissociating water vapor, carbon dioxide, and even hydrogen molecules into individual atoms. The temperature is so extreme that heavy metals like iron and titanium exist as gases in the upper atmosphere. The planet is slowly being evaporated by its own temperature, losing atmosphere at a rate that will eventually destroy it entirely. The night side of the planet, permanently facing away from the star, is still blazing hot at about 3,000 degrees Fahrenheit due to heat circulation from the day side. KELT-9b experiences the most extreme temperature gradient of any known planet, with day-night temperature differences exceeding 4,000 degrees Fahrenheit. The star's intense ultraviolet radiation bombards the planet so severely that it's essentially being cooked alive, with atmospheric material streaming away into space in a continuous tail of vaporized matter. This world represents the extreme limit of planetary survival, a place where rock becomes gas and the very concept of weather involves temperatures that exceed most stellar surfaces. 58. Planets orbiting like a cosmic carousel. The KOI-134 system shattered astronomers' expectations by hosting the first known compact multi-planet system that doesn't lie in a flat plane. Instead of orbiting in the same disk like planets in our solar system, 2 planets in this system orbit on different, tilted planes around their star, resembling an old-fashioned merry-go-round or cosmic carousel. This discovery challenged the fundamental assumption that planetary systems form in flat disks and remain that way throughout their evolution. The 2 planets orbit at different inclinations, creating a 3-dimensional orbital configuration that shouldn't exist according to conventional planet formation theories. Computer simulations suggest this unusual architecture might result from gravitational interactions with a distant companion star or massive planet that gradually tilted the orbits over millions of years. The tilted orbits create complex gravitational interactions between the planets that cause their orbital planes to slowly precess around the star like wobbling spinning tops. This system demonstrates that planetary architectures can be far stranger than our solar system's orderly arrangement. It raises questions about how common such 3-dimensional systems might be and whether our solar system's flat configuration is actually unusual. The discovery suggests that planetary systems can evolve in ways we never imagined, creating cosmic dance patterns that defy our Earth-centric expectations about how planets should behave. 59. Super-Earths are everywhere except here. After studying thousands of exoplanet systems, astronomers have made a startling discovery. The most common type of planet in the galaxy is one that doesn't exist in our solar system. Super-Earths, planets between Earth and Neptune in size, are found in about 30% of all star systems, making them the most abundant type of planet in the Milky Way. These worlds typically range from 1.5 to 4 times Earth's diameter and often orbit much closer to their stars than Mercury orbits our Sun. Many super-Earths complete orbits in just days or weeks, existing in extreme environments that would vaporize anything Earth-like. Our solar system's architecture, with small rocky planets close to the Sun and gas giants farther out, appears to be relatively rare. Most planetary systems have their largest planets crammed close to their stars, with super-Earths dominating the inner regions where we have nothing but empty space between Venus and Jupiter. This super-Earth gap in our solar system makes it an oddball among planetary systems. Scientists theorize that Jupiter's early migration through the inner solar system might have prevented super-Earths from forming here, or ejected them entirely. The abundance of super-Earths elsewhere suggests our solar system underwent unusual evolutionary processes that created a planetary arrangement quite different from the galactic norm. We live in a cosmic minority, making our planetary system's orderly spacing and size distribution surprisingly rare. 60. Oumuamua behaved impossibly. In 2017, humanity encountered its first confirmed interstellar visitor when asteroid Oumuamua passed through our solar system. This cigar-shaped object, about 1,300 feet long and only 130 feet wide, behaved in ways that continue to puzzle scientists. As Oumuamua departed the solar system, it accelerated beyond what gravity alone could explain, speeding up as it moved away from the Sun normally. Comets show such acceleration when solar heating vaporizes ices on their surface, creating jets that push the object forward. However, Oumuamua showed no signs of gas emission, no visible tail, and no detectable water vapor or other outgassing products. The object tumbled chaotically as it moved through space, rotating every 7.3 hours, suggesting it had experienced violent collisions in its interstellar journey. Its extreme elongated shape, at least 10 times longer than it is wide, is unlike any asteroid or comet in our solar system. Some scientists propose that Oumuamua might be a fragment of nitrogen ice from a Pluto-like world, while others suggested it could be a piece of alien technology, though natural explanations are considered more likely. The mysterious acceleration might result from outgassing of hydrogen created by cosmic ray bombardment, or from subtle effects of solar radiation pressure on the object's unusual shape. Oumuamua reminded us that the universe contains objects and phenomena we've never encountered before. 61. Dark comets look like asteroids but move like comets. Scientists recently identified a new category of solar system objects that challenge our understanding of the distinction between asteroids and comets. Dark comets appear completely asteroid-like to telescopes, showing no visible tails, comas, or signs of outgassing. Yet they move through space with the non-gravitational acceleration typical of comets. These mysterious objects somehow contain enough volatile materials to create thrust through outgassing, but not enough to produce visible comet-like features. The first dark comet, designated 2003 RM, was initially classified as an asteroid until astronomers noticed its orbit was changing in ways that could only be explained by comet-like outgassing. Since then, astronomers have identified several dozen similar objects that blur the line between asteroids and comets. Dark comets might represent a missing link in our understanding of how icy materials are distributed throughout the solar system. They could be dormant comets that have lost most of their surface ice through repeated passes near the Sun, or asteroids that contain small amounts of buried ice. Some scientists theorize that dark comets might have been responsible for delivering water and organic materials to early Earth, representing a previously unknown population of objects that contributed to making our planet habitable. These enigmatic objects demonstrate that the solar system contains many more types of small bodies than we previously recognized. 62. Interstellar objects are incredibly fast. Confirmed interstellar visitors travel through our solar system at mind-bending velocities exceeding 150,000 miles per hour. So fast they're not gravitationally bound to the Sun and pass straight through our cosmic neighborhood like bullets through tissue paper. These objects carry the motion from their birth star systems plus additional velocity gained from gravitational encounters during their potentially millions of years wandering through interstellar space. Oumuamua entered our solar system at about 59,000 miles per hour relative to the Sun, but accelerated to over 196,000 miles per hour as it whipped around the Sun and headed back into interstellar space. Comet 2I/Borisov, the second confirmed interstellar visitor, traveled even faster at roughly 110,000 miles per hour. At these velocities, interstellar objects spend only months or years passing through our solar system. Oumuamua was visible for only a few weeks before disappearing forever into the cosmic dark. The extreme speeds make these objects incredibly difficult to study, requiring rapid mobilization of telescopes worldwide to gather data before they vanish. Future missions to intercept interstellar visitors would need to overcome enormous technical challenges, as spacecraft would need to accelerate to unprecedented velocities just to match their motion. These cosmic nomads represent time capsules from alien star systems, carrying information about planetary formation and stellar evolution from across the galaxy, but their brief visits make them among the most challenging objects in the solar system to investigate. 63. Some asteroids are held together by static electricity. Many asteroids aren't solid rocks but loose collections of debris held together by forces weaker than the attraction between socks in a dryer. These rubble pile asteroids consist of countless boulders, pebbles, and dust particles barely clinging together through weak gravitational attraction and, surprisingly, static electricity. The asteroid Bennu, visited by NASA's OSIRIS-RX mission, rotates so slowly that if it spun just 10% faster, centrifugal force would overcome the weak gravity holding it together, causing the asteroid to fly apart like a cosmic pinwheel. Static electricity plays a crucial role in keeping fine particles attached to the asteroid's surface, especially near the equator where gravitational forces are weakest. When OSIRIS-RX attempted to collect samples from Bennu's surface, the spacecraft's touch-and-go maneuver revealed that the asteroid's surface was far less solid than expected. The sampling arm sank 19 inches into what appeared to be firm ground, finding a consistency more like a ball pit than solid rock. Many asteroids appear to be gravitational dust bunnies, held together by forces so weak that a strong sneeze could theoretically disrupt their structure. This discovery has major implications for planetary defense. Deflecting a solid asteroid requires different strategies than redirecting a loosely bound pile of debris that might simply disintegrate under stress rather than changing course as a unified object. 64. The first Jupiter-Trojan comet. In 2019, astronomers discovered an object that fundamentally challenged our understanding of the solar system's organization. Designated 2019 LD2, this object appeared to be a typical Jupiter-Trojan asteroid, one of thousands of rocky bodies that share Jupiter's orbit, trapped in gravitationally stable points 60 degrees ahead of or behind the giant planet. However, 2019 LD2 suddenly sprouted a comet-like tail, becoming the first known active comet among Jupiter's Trojan population. This discovery was revolutionary because comets and asteroids were thought to form in different regions of the solar system. Comets in the cold outer regions where ices remain stable, and asteroids in the warm inner regions where volatile materials vaporize. The Jupiter Trojans were considered to be asteroidal dry, rocky objects that had been captured into Jupiter's orbit billions of years ago. The transformation of 2019 LD2 from asteroid-like to comet-like behavior suggests that many objects we classify as asteroids might actually contain significant amounts of buried ice. The comet's activity might have been triggered by a recent impact that exposed subsurface ice to solar heating, or by gradual thermal evolution that allowed buried volatiles to finally reach the surface. This discovery indicates that the distinction between comets and asteroids is less clear than previously thought, and that icy materials might be more widely distributed throughout the solar system than current theories predict. 65. The Sun's atmosphere is 300 times hotter than its surface. The Sun presents one of the most puzzling mysteries in all of astrophysics. Its atmosphere is hundreds of times hotter than its surface, violating every intuitive expectation about how heat should behave. The Sun's surface temperature measures about 10,000 degrees Fahrenheit, but its upper atmosphere, called the corona, reaches temperatures exceeding 3 million degree F. This is like finding that the air above a campfire is 300 times hotter than the flames themselves. The temperature inversion defies basic thermodynamics. Heat should flow from hot to cold, not the reverse. The corona is so hot that it emits X-rays and extreme ultraviolet radiation, making it visible only during total solar eclipses when the bright surface is blocked. Scientists have proposed various mechanisms to explain this heating paradox, including magnetic reconnection events, acoustic waves generated by convection, and the tangling and snapping of magnetic field lines. The Parker Solar Probe, launched in 2018, is flying closer to the Sun than any previous spacecraft to directly measure the corona's properties and solve this decades-old mystery. The probe has revealed that the corona is even more complex than expected, with magnetic switchbacks, plasma jets, and turbulent structures that create localized heating events. Understanding the corona's heating mechanism is crucial for predicting space weather that can affect satellites, power grids, and technology on Earth. 66. Solar storms can disable technology on Earth. The most powerful solar storm in recorded history occurred on September 1, 1859, when a massive coronal mass ejection struck Earth with such force that it essentially turned our planet into a giant electrical generator. The Carrington event, named after the astronomer who observed the solar flare that caused it, induced electrical currents so powerful that telegraph lines across North America and Europe sparked, caught fire, and shocked operators. Some telegraph systems continued operating even after being disconnected from their power sources, running entirely on electricity induced by the magnetic storm. The aurora borealis appeared as far south as the Caribbean, and was so bright that people could read newspapers by its light. Gold miners in Colorado woke up thinking it was dawn because the sky glowed so intensely. If a similar event occurred today, the consequences would be catastrophic. Modern society's dependence on electronic technology makes us far more vulnerable than the telegraph-era civilization of 1859. A Carrington-level storm could damage power transformers across continents, disable satellites, disrupt GPS navigation, and knock out internet and cellular communications for months or years. The economic damage could exceed $2 trillion in the United States alone. NASA and NOAA constantly monitor the sun for signs of major eruptions, but we would have only 15 to 30 hours warning before a major storm reached Earth, insufficient time to protect all vulnerable systems. 67. The sun loses 4 million tons per second. Every single second, the sun converts 4 million tons of matter into pure energy through nuclear fusion. demonstrating Einstein's famous equation E equals mc squared on a scale that dwarfs human comprehension. This mass-to-energy conversion occurs in the Sun's core, where temperatures reach 27 million degree F and pressures are 250 billion times greater than Earth's atmospheric pressure. Under these extreme conditions, hydrogen nuclei overcome their electrical repulsion and fuse into helium, releasing enormous amounts of energy in the process. The 4 million tons of matter that vanish each second equals about 400 Empire State Buildings instantly transformed into light and heat. Despite this tremendous mass loss, the Sun contains enough hydrogen fuel to continue burning for approximately 5 billion more years. The Sun's total mass is so enormous, about 2 times 10 to the power of 30 kilograms, that losing 4 million tons per second barely affects its overall structure. Over the Sun's entire 10 billion-year main sequence lifetime, it will convert only about 0.7% of its total mass into energy. The energy produced in the Sun's core takes an average of 100,000 years to work its way to the surface through countless absorption and re-emission events, then travels the 93 million miles to Earth in just 8 minutes and 20 seconds. Every photon of sunlight hitting Earth carries energy that was created deep inside the Sun before human civilization existed. 68. The CMB contains most photons in the universe. The cosmic microwave background radiation contains the vast majority of photons in the entire universe, about 400 times more photons than all other sources combined, including every star, galaxy, and quasar that has ever existed. These ancient photons were released when the universe was only 380,000 years old and cooled enough for electrons and protons to combine into neutral hydrogen atoms for the first time. Before this moment, called recombination, the universe was opaque to light because free electrons scattered photons in all directions. When recombination occurred, the universe suddenly became transparent, releasing a flood of photons that have been traveling through space ever since. The number density of CMB photons is approximately 411 photons per cubic centimeter throughout the universe, compared to roughly 0.0004 matter particles per cubic centimeter. This means photons outnumber matter particles by more than 1,000,000 to 1. These CMB photons have been redshifted by cosmic expansion from visible light to microwave radiation, but they still carry the thermal signature of the early universe at a temperature of 2.7 Kelvin above absolute zero. Every cubic meter of space contains about 400 million of these ancient photons, making them the most abundant form of radiation in the cosmos. The CMB represents the oldest light we can observe, providing a baby picture of the universe taken just 0.003% into its current age. 69. The night sky should shine like the sun. Without the expansion of the universe, every direction you looked in the night sky should be as bright as the sun's surface, a cosmic illumination that would make night and day indistinguishable. This puzzle, known as Olber's paradox, troubled astronomers for centuries. If the universe is infinite and contains an infinite number of stars uniformly distributed through space, then every line of sight should eventually intersect a star's surface, making the entire sky blindingly bright. The resolution comes from cosmic expansion, which redshifts light from distant sources and stretches the cosmic microwave background radiation to longer wavelengths that our eyes can't detect. The expansion also creates a cosmic horizon beyond which we cannot see, limiting the number of stars contributing to the night sky's brightness. Additionally, the universe has a finite age, so light from extremely distant stars hasn't had time to reach us yet. If you could somehow see the cosmic microwave background with your naked eyes, the entire night sky would glow with the brilliance of a 2.7 Kelvin blackbody, essentially invisible to human vision but containing enormous amounts of energy. The darkness of night is actually evidence for the Big Bang and cosmic expansion, proving that the universe had a beginning and has been growing larger throughout its history. Our dark night sky is a cosmic gift that allows us to see stars as individual points of light rather than being overwhelmed by infinite cosmic brilliance. 70. We see the universe's baby picture. The cosmic microwave background represents the oldest possible photograph of the universe, showing it when it was only 380,000 years old, a mere 0.003% of its current age. This baby picture captures the moment when the universe first became transparent to light, transitioning from an opaque plasma to a clear medium through which photons could travel freely. Before this epoch, called the surface of last scattering, The universe was a hot, dense fog of hydrogen and helium nuclei surrounded by free electrons that scattered light in all directions. When the temperature dropped to about 3000 Kelvin, electrons and nuclei combined to form neutral atoms, suddenly clearing the cosmic fog and releasing a flood of photons. These photons have been traveling through space for 13.8 billion years, carrying information about the universe's structure, composition, and physical conditions at that ancient epoch. The CMB shows tiny temperature fluctuations of only 0.00001 Kelvin, variations that represent the seeds of all future cosmic structure. These minute fluctuations were quantum mechanical in origin, created during cosmic inflation and preserved as density variations that would eventually grow into galaxies, stars, and planets. The CMB is our most direct observational link to the universe's birth, providing precise measurements of cosmic parameters like the universe's age, composition, and rate of expansion. It's the cosmic equivalent of looking at humanity's earliest baby photos, revealing our universe's infant features before galaxies, stars, or any complex structure existed. 71. GPS satellites age differently. The Global Positioning System provides daily proof that Einstein's relativity affects everyday technology. GPS satellites orbit Earth at altitudes of about 12,500 miles, traveling at speeds of approximately 8,700 miles per hour in a weaker gravitational field than we experience on Earth's surface. According to special relativity, the satellite's high velocity causes their onboard atomic clocks to tick slower by about 7 microseconds per day. However, general relativity predicts that the weaker gravity at orbital altitude causes clocks to tick faster by about 45 microseconds per day. The net effect is that satellite clocks gain about 38 microseconds daily compared to ground-based clocks. This may seem trivial, but GPS requires timing precision of about 20 to 30 nanoseconds to maintain meter-level accuracy. Without relativistic corrections, GPS would accumulate errors of about 6 miles per day, making the system completely useless within hours. The GPS system must continuously adjust for these relativistic effects using data from ground monitoring stations. Every time you use GPS navigation, your device is essentially performing calculations based on Einstein's theories of space and time. The system represents one of the most practical applications of relativity theory, proving that abstract physics concepts developed in the early 20th century are essential for 21st century technology. Modern life depends on our understanding of how time flows differently in different gravitational fields and reference frames. 72. Earth's core is younger than its surface. Due to gravitational time dilation, Earth's core ages more slowly than its surface, creating a measurable age difference across our planet. Einstein's general relativity predicts that time passes more slowly in stronger gravitational fields, and Earth's gravity is slightly stronger at the center than at the surface. This effect is tiny but real. Clocks at sea level tick about 90 nanoseconds per day slower than identical clocks on mountaintops. Over Earth's 4.5 billion-year history, this time difference has accumulated to about 2.5 years. The effect has been confirmed using atomic clocks at different altitudes, with timepieces at higher elevations consistently running faster than those closer to Earth's center. At the scale of atomic physics, this time dilation affects radioactive decay rates, meaning radioisotopes in Earth's core decay slightly more slowly than identical isotopes on the surface. The gravitational time dilation also affects GPS satellites, particle accelerators, and any high-precision timing system. While 2.5 years may seem insignificant on geological timescales, it represents a real, measurable consequence of living in curved spacetime. This time difference demonstrates that the passage of time is not uniform throughout Earth. We literally age at different rates depending on our altitude and distance from massive objects. The effect becomes much more pronounced near extremely dense objects like neutron stars or black holes, where time dilation can become so extreme that it dominates the physics of the system. 73. Muons prove time dilation. High-energy cosmic rays constantly bombard Earth's upper atmosphere, creating exotic particles called muons that provide daily proof of Einstein's time dilation. Muons are unstable particles similar to electrons but 200 times heavier, with an average lifetime of only 2.2 microseconds before they decay into other particles. When muons are created about 9 miles high in the atmosphere by cosmic ray collisions, basic physics says they should decay long before reaching Earth's surface, Even traveling at 99.5% light speed, most muons should disappear after traveling only about 2,000 feet. Yet muon detectors on Earth's surface register thousands of these particles every day, proving they survive the 9-mile journey from the upper atmosphere. The resolution to this apparent paradox comes from time dilation. From our reference frame, the muons' internal clocks run slower due to their extreme velocity, allowing them to live longer than expected. From the muons' reference frame, the distance to Earth's surface contracts due to length contraction, making the journey shorter than expected. Either way, relativity allows these short-lived particles to reach Earth's surface in detectable numbers. This natural experiment occurs continuously above our heads, with cosmic ray muons serving as high-speed proof that time and space behave exactly as Einstein predicted. Without time dilation, the muon flux at Earth's surface would be thousands of times weaker than observed, making this one of the most accessible demonstrations of relativistic physics. 74. Light is cosmically slow. Despite traveling at the universe's ultimate speed limit of 299,792,458 meters per second, light is frustratingly slow when it comes to cosmic distances. Light takes 8 minutes and 20 seconds to travel from the Sun to Earth, a delay that means we always see the Sun as it was 8 minutes ago, not as it is right now. If the Sun suddenly disappeared, we wouldn't know for 8 minutes. Light from the nearest star, Proxima Centauri, takes 4.3 years to reach Earth, meaning we see it as it was when you were 4.3 years younger. Radio signals sent to Mars take between 4 and 24 minutes to arrive, depending on the planet's positions in their orbits, making real-time communication with Mars missions impossible. During Mars rover operations, engineers must plan entire sequences of commands and send them all at once, then wait up to 48 minutes for confirmation that the commands were received and executed. Light from the Andromeda Galaxy, our nearest major galactic neighbor, takes 2.5 million years to reach us, showing us Andromeda as it existed when early human ancestors were evolving in Africa. The observable universe has a radius of 46.5 billion light-years, but this represents the maximum distance from which light could have reached us since the Big Bang. Even at light speed, the fastest anything can travel, the universe is so vast that information takes eons to cross cosmic distances, creating a universe where cause and effect are separated by millions or billions of years. 75. The universe expands faster than light. While nothing can move through space faster than light, space itself can expand faster than light speed, and it does so throughout most of the observable universe. At distances beyond about 14 billion light-years from Earth, galaxies are receding from us faster than 299,792,458 meters per second due to cosmic expansion. This doesn't violate relativity because the galaxies aren't moving through space at superluminal speeds. Instead, space itself is stretching between us and them. The expansion rate, described by Hubble's constant, means that for every megaparsec, 3.26 million light-years, of distance, space expands at about 70 kilometers per second. Beyond a certain distance, called the Hubble sphere, this expansion velocity exceeds light speed. Galaxies beyond this boundary are effectively disappearing from our observable universe. Their light can never catch up to the expanding space between us. We can observe galaxies beyond the Hubble sphere only because we're seeing light they emitted billions of years ago when they were closer to us and space was expanding more slowly. As cosmic expansion accelerates due to dark energy, more and more galaxies will cross this cosmic horizon and fade from view. Eventually, observers in the far future will see only galaxies in their local group, with the rest of the universe disappearing beyond an ever-shrinking horizon of observability. 76. The cosmic speed limit has exceptions. While the speed of light in vacuum represents the fundamental speed limit of spacetime, the actual cosmic speed limit for particles is slightly lower due to interactions with the cosmic microwave background radiation. Ultra-high-energy cosmic rays, particles accelerated to enormous energies by unknown cosmic processes, face a practical speed limit called the GZK cutoff, named after physicists Griezin, Zatsepin, and Kuzmin who predicted it. When cosmic ray protons exceed energies of about 6 times 10 to the power of 19 electron volts, they begin interacting with CMB photons through a process that produces pions, gradually slowing the cosmic rays. This creates an effective speed limit about 0.9999999999999999999% the speed of light, just barely below light speed, but enough to prevent cosmic rays from reaching truly extreme energies. The GZK cutoff means that the highest energy cosmic rays we observe on Earth must originate within about 150 million light-years of our galaxy, because more distant sources would lose energy through CMB interactions during their journey. This discovery reveals that even empty space filled with ancient photons can affect particle motion, creating a cosmic traffic law that governs the highest energy processes in the universe. The CMB acts like a cosmic speedometer, preventing any massive particle from achieving truly relativistic velocities over intergalactic distances. It's a reminder that even in the vast emptiness between galaxies, subtle quantum fields and ancient radiation continue to influence the behavior of matter and energy. 77. Empty space isn't empty. What we call empty space or vacuum is actually a seething foam of quantum activity, filled with virtual particles that constantly pop into existence and annihilate each other in timescales so brief they cannot be directly observed. The Heisenberg uncertainty principle allows these particle-antiparticle pairs to borrow energy from the quantum vacuum for incredibly short periods before returning it through mutual annihilation. This quantum vacuum contains measurable energy, the Higgs field that gives particles mass, gravitational waves passing through from cosmic events, neutrinos from nuclear reactions, cosmic microwave background photons, and dark energy that drives cosmic expansion. Even in the most perfect vacuum achievable in laboratory conditions, quantum field fluctuations create a background of activity that makes truly empty space impossible. The vacuum energy density, while enormous according to quantum field theory calculations, somehow nearly perfectly cancels out to produce the small positive value we observe as dark energy. Every cubic centimeter of empty space contains about 400 cosmic microwave background photons, plus immeasurable amounts of dark matter and dark energy. Virtual particles in the quantum vacuum can become real particles when energy is supplied, a process exploited in particle accelerators and predicted to occur near black hole event horizons through Hawking radiation. The concept of empty space is a classical illusion. Reality consists of quantum fields permeating all of spacetime, with what we perceive as particles being excitations in these underlying fields. 78. The Casimir effect proves virtual particles. The Casimir effect provides tangible proof that virtual particles and quantum vacuum energy are real, measurable phenomena rather than just mathematical abstractions. When two metal plates are placed extremely close together in a perfect vacuum, separated by distances smaller than a micrometer, they experience a measurable attractive force that pulls them together. This force arises because the narrow gap between the plates restricts which virtual particle wavelengths can exist in the space between them, while the area outside the plates allows virtual particles of all wavelengths. This creates a pressure imbalance, lower vacuum energy between the plates compared to the surrounding space, resulting in a net inward force. The effect is incredibly weak but has been measured with high precision using sensitive instruments. Two plates separated by 1 micrometer experience an attractive pressure of about 0.001 pascals, roughly equivalent to the pressure exerted by a sheet of paper. While tiny, this force is large enough to affect the operation of microelectromechanical systems, MEMS, and must be accounted for in precision engineering applications. The Casimir effect demonstrates that empty space has real, measurable properties and contains genuine energy fluctuations. It bridges the gap between quantum field theory and everyday physics, proving that the vacuum is far from empty but filled with quantum activity that can produce real, observable forces. This effect is being studied for potential applications in nanotechnology and may represent a pathway to extracting energy from quantum vacuum fluctuations. 79. Quantum foam at the Planck scale. At the smallest possible scale of length, the Planck length of 1.616 times 10 to the power of -35 meters, spacetime itself becomes a chaotic, foamy structure where the smooth geometry of Einstein's relativity breaks down completely. At this scale, quantum uncertainty principle allows spacetime to fluctuate wildly, creating and destroying tiny black holes, wormholes, and exotic topological structures in timeframes of 10 to the power of -43 seconds, Planck time. These fluctuations are so violent that the normal concepts of distance, time, and causality become meaningless. The quantum foam represents the marriage of quantum mechanics and general relativity, predicting that spacetime has a granular structure at its most fundamental level rather than being the smooth continuum it appears at larger scales. Virtual particles in the quantum foam can spontaneously create particle-antiparticle pairs with energies so enormous they temporarily form microscopic black holes that instantly evaporate through Hawking radiation. The foam structure might explain the origin of physical constants, the nature of time, and the fundamental properties of matter and energy. Some theories suggest that the quantum foam is the source of cosmic inflation, dark energy, and the Big Bang itself. At the Planck scale, physics becomes a realm where space-time literally boils with quantum activity, creating a probabilistic foundation for all of reality. Every particle, every force, and every structure in the universe emerges from this quantum mechanical foundation where space and time themselves are emergent properties rather than fundamental aspects of reality.
80. LIGO-S Impossible Sensitivity.
The Laser Interferometer Gravitational Wave Observatory, LIGO, achieves a level of precision that defies human comprehension, measuring changes in distance that are 1/10,000th the width of a proton nucleus. LIGO's two L-shaped detectors, each with 4-kilometer-long arms, can detect when gravitational waves stretch and compress space by distances smaller than 1/10,000th of the nuclear size. To put this in perspective, if the distance to the nearest star were measured with the same relative precision, you could detect changes smaller than the width of a human hair. LIGO's sensitivity is so extreme that it can detect vibrations caused by trucks driving miles away, earthquakes on the opposite side of Earth, waves crashing on distant coastlines, and even the quantum mechanical motion of its own atoms. The detectors must be isolated from seismic vibrations, temperature fluctuations, electromagnetic interference, and countless other sources of noise that would completely overwhelm the gravitational wave signals. The mirrors in LIGO are suspended by multi-stage pendulum systems that filter out ground motion, and the entire apparatus is operated in ultra-high vacuum chambers. When gravitational waves pass through Earth, they alternately stretch and compress the detector arms in perpendicular directions, creating an interference pattern in laser light that reveals the wave's amplitude and frequency. The fact that LIGO can detect these unimaginably tiny distortions in spacetime represents one of humanity's greatest technological achievements and has opened an entirely new window for observing the universe. 81. The universe's golden forges. Deep in the cosmic darkness, two dead stars dance their final waltz. These aren't ordinary stars, they're neutron stars, each one a city-sized sphere containing more mass than our entire Sunday. For millions of years, they've spiraled closer, locked in an inevitable embrace of destruction. When they finally collide, the universe witnesses something extraordinary: the birth of gold. The collision unleashes a kilonova, an explosion so violent it outshines entire galaxies. In those few seconds of cosmic fury, temperatures soar beyond comprehension, and the very fabric of matter is torn apart and rebuilt. Heavy elements like gold and platinum are forged in this stellar alchemy, scattered across space like cosmic confetti. A single kilonova produces more gold than the entire mass of Earth. Every wedding ring, every piece of jewelry, every golden treasure on our planet was born in these moments of celestial violence, making us all children of colliding stars. 82 hearts transformed by the void. Without that constant downward force, blood and bodily fluids redistributed throughout her body like water finding its level. Her heart, no longer needing to fight against gravity, began to relax and transform. Day by day, it became rounder, more spherical, nearly perfectly round. The change wasn't just cosmetic. Her heart was working 40% less efficiently than on Earth. This wasn't science fiction. This was the reality every astronaut faces. In space, the human heart literally reshapes itself, becoming a sphere floating in the chest cavity, a reminder that we are truly creatures of Earth, shaped by forces we rarely consider. 83. The balloon face syndrome. 3 hours into his first spaceflight, astronaut David Chun caught his reflection in the station window and gasped. The face staring back at him looked like a stranger's, puffy, swollen, almost cartoonish. His cheeks had inflated like balloons. His eyes were nearly buried in swollen tissue, and his normally sharp jawline had disappeared beneath layers of fluid-filled flesh. This was puffy face syndrome, and it happened to every human who ventured beyond Earth's gravitational embrace. On our planet, gravity constantly pulls bodily fluids downward, pooling them in our legs and feet by day's end. But in space, those same fluids had nowhere to go but up. Like water in a zero-gravity bubble, the fluids redistributed evenly throughout his body, rushing to fill his head and face. Within hours, astronauts often couldn't recognize their own crewmates. The transformation was so dramatic that mission planners had learned to expect a period of adjustment as crews adapted to their new, swollen appearances. It was a humbling reminder that human bodies are precisely calibrated for life on one specific planet. 84. Bones dissolving in the void. Dr. Lisa Rodriguez had spent 6 months aboard the International Space Station, conducting groundbreaking experiments and marveling at Earth's beauty. But inside her body, a silent catastrophe was unfolding. Her bones were literally dissolving. Every month in space, astronauts lose 1 to 1.5% of their bone mineral density, the equivalent of what elderly people lose in an entire year on Earth. Her hip bones were particularly vulnerable, potentially losing up to 20% of their mass during her mission. The calcium that had once made her skeleton strong was leaching into her bloodstream and being excreted as waste, leaving her bones hollow and brittle. This wasn't a gradual process, it was alarmingly rapid. Back on Earth, her bones had been constantly rebuilding themselves, responding to the stress of supporting her body weight against gravity. But in weightlessness, her skeleton received the biological message that it was no longer needed. Her body began cannibalizing itself, dissolving the very framework that had supported her for decades. Recovery would take years, and some bone loss might be permanent, the hidden cost of touching the stars. 85. Growing taller among the stars. Commander James Park pushed himself through the station's narrow hatch and winced as his back erupted in agony. In just 3 weeks aboard the International Space Station, he had grown 2 inches taller, and every additional inch brought excruciating pain. On Earth, gravity constantly compressed his spine, pressing his vertebrae together like a stack of cushions under weight. But in microgravity, that pressure vanished. His spinal discs, no longer squeezed by his body weight, began to expand like sponges absorbing water. The cartilage between his vertebrae swelled, stretching his spine longer than it had been since childhood. The growth wasn't uniform or comfortable. As his spine elongated, the expanding discs pressed against nerve roots, sending shooting pains down his legs and making simple movements agonizing. Some astronauts reported pain so severe they couldn't sleep. The irony was bitter. In reaching for the stars, he had literally grown closer to them, but at the cost of constant suffering. When he returned to Earth, gravity would compress him back to his original height, but the memory of space-induced growing pains would last forever. 86. The vision thief of space. Dr. Marina Volkov had perfect vision when she launched to the International Space Station. 20/20 eyesight, crystal clear at every distance. The kind of vision that had helped her become one of the world's top space doctors. But 6 months later, as she prepared for her return to Earth, she could barely read the instrument panels without squinting. Space had stolen her sight. The fluid shift that caused puffy faces and swollen hearts had a more sinister effect. It increased pressure inside her skull, literally reshaping her eyeballs. The increased intracranial pressure flattened the back of her eyes and crushed her optic nerves. Her perfect spherical eyeballs became slightly oval, changing their focal length like a camera lens knocked out of alignment. This was space-associated neuroocular syndrome, SANS, affecting nearly 70% of astronauts. Some recovered partially, others didn't recover at all. Marina joined a growing fraternity of space explorers who had traded their perfect vision for a glimpse of the cosmos. The price of touching infinity, it seemed, was the ability to see it clearly when you returned home. 87. Apollo 13's hidden death sentence. The world knows about the oxygen tank explosion that crippled Apollo 13, but few know how close the crew came to dying before they even left Earth's atmosphere. During launch, the massive Saturn V rocket began experiencing violent pogo oscillations, the entire vehicle bucking and shaking like a wild bronco trying to throw its riders. The center engine was absorbing impossible forces, experiencing 34 times the force of Earth's gravity. The engine mount was literally being torn apart by oscillations so violent they could have destroyed the entire rocket. If the automatic shutdown system had failed by even seconds, the engine would have exploded, taking Jim Lovell, Fred Hayes, and Jack Swigert with it. NASA engineers watched in horror as telemetry showed the rocket destroying itself from within. The pogo effect was like a deadly resonance, growing stronger with each oscillation until something had to give. Fortunately, the engine shut down automatically, but the crew never knew how close they came to being vaporized in a fireball 200 miles above the Pacific Ocean. They survived to face their famous oxygen tank crisis only because of a computer's split-second decision during those terrifying moments of ascent. 88. The hidden fire that could have saved lives. In a secret training facility in Star City, Russia, 23-year-old cosmonaut Valentin Bondarenko was completing a routine exercise in a pure oxygen chamber. It was March 23, 1961, 3 weeks before Yuri Gagarin would become the first human in space. Bondarenko removed medical sensors from his body and cleaned the adhesive spots with an alcohol-soaked cotton pad. Then he casually tossed the pad aside. In the oxygen-rich environment, the smallest spark became a deadly inferno. The cotton pad hit a hot plate and instantly ignited. Flames raced across every surface, turning the chamber into a furnace. Bondarenko died from his burns 10 days later, becoming the first human casualty of the space age. The Soviets buried the tragedy in classified files for 25 years. If NASA had known about this oxygen fire, they might have taken different precautions. Instead, on January 27, 1967, Gus Grissom, Ed White, and Roger Chaffee died in an identical oxygen fire during an Apollo 1 ground test. 3 American lives might have been saved if the Soviets had shared the bitter lesson learned in Bondarenko's final moments. 89. The day astronauts went on strike. Gerald Carr, Edward Gibson, and William Pogue were exhausted. For weeks aboard Skylab, NASA had scheduled them for 16-hour workdays, packing every moment with experiments, maintenance, and observations. They were falling behind, making mistakes, and their stress levels were reaching dangerous heights. On December 28, 1973, they made space history by staging the first labor strike beyond Earth's atmosphere. The 3 astronauts simply turned off their radios and refused to communicate with mission control for an entire day. For 24 hours, the most expensive scientific laboratory in human history went silent. The crew floated in their orbiting workshop, looking down at Earth, taking time to rest and contemplate their situation without the constant chatter of ground controllers demanding their attention. NASA was horrified. The press called it a space mutiny, but the astronauts had made their point. Even in the most extraordinary circumstances imaginable, humans needed reasonable working conditions. When communication resumed, schedules were adjusted and workloads reduced. The Skylab strike became a watershed moment, proving that even among the stars, workers' rights mattered. 90. The $19,000 bathroom break. Every time astronauts aboard the International Space Station need to use the toilet, it costs approximately $19,000. This isn't because of expensive toilet paper or premium plumbing. It's because the waste and hygiene compartment represents one of the most complex pieces of engineering ever created. In space, there's no gravity to make waste fall away from the body. Instead, the toilet uses airflow to pull waste away from astronauts, requiring a complex system of fans, filters, and vacuum pumps. The waste must be carefully contained, processed, and stored without contaminating the station's atmosphere. Urine is actually recycled into drinking water through a sophisticated filtration system, while solid waste is stored in special containers and eventually loaded onto cargo ships that burn up during re-entry. The system required years of development, extensive testing, and constant maintenance by highly trained specialists. When you factor in the development costs, spare parts, maintenance time, and the cost of launching replacement components to orbit, each bathroom visit represents a significant investment in space-age sanitation. It's a humbling reminder that the most basic human functions become extraordinary challenges 250 miles above Earth. 91. The Space Shuttle's explosive insurance policy. Hidden throughout every space shuttle were hundreds of small explosive devices called pyrotechnic nuts, controlled explosives designed to instantly sever connections in emergencies. These weren't tiny firecrackers. They were precisely engineered charges that could instantly disconnect fuel lines, release cargo bay doors, or separate the shuttle from its external tank. During a typical mission, the shuttle carried over 300 of these explosive devices. They were everywhere, in the landing gear, the cargo bay mechanisms, the engine systems, and even in the crew escape systems. Each one was designed to fire on command, instantly cutting through bolts and cables that would otherwise require tools and time to disconnect. The irony was profound. To make space travel safer, NASA had to fill their spacecraft with explosives. These pyrotechnic devices were the shuttle's insurance policy, a way to quickly jettison dangerous components or escape catastrophic failures. Astronauts literally flew surrounded by hundreds of small bombs, each one a potential lifesaver in the unforgiving environment of space. It was a testament to both human ingenuity and the extreme measures required to survive beyond Earth's protective atmosphere. 92. The liquid metal that changed everything. In the 1960s, NASA engineers faced an impossible problem. How do you move liquid fuel in space when there's no gravity to make it flow? Traditional pumps rely on gravity to keep liquid at the bottom of tanks, but in weightlessness, fuel could float anywhere, creating dangerous air bubbles in fuel lines. The solution was revolutionary. They created ferrofluid, a liquid that could be controlled by magnetism. By mixing microscopic iron oxide particles into various liquids, they created fluids that behaved like liquid magnets. Magnetic fields could push, pull, and position these fluids exactly where needed, regardless of gravity's presence or absence. This space-age invention soon found its way into everyday life in ways NASA never imagined. Ferrofluid became crucial for computer hard drives, creating seals that kept dust out while allowing moving parts to function smoothly. It revolutionized audio speakers, providing better cooling and damping for voice coils. Today, ferrofluid is found in car shock absorbers, optical devices, and medical equipment. What began as a solution to move rocket fuel in zero gravity became a technology that touches millions of lives daily, proving that solutions to space's challenges often improve life on Earth. 93. The perfect flames of zero gravity. Dr. Foreman Williams watched in fascination as the flame floated before him like a glowing sphere. In the microgravity laboratory aboard the International Space Station, fire behaved like nothing he had ever seen on Earth. The flame was perfectly round, burning cooler and bluer than any earthbound fire, sometimes so dim it was nearly invisible. On Earth, hot gases rise due to buoyancy, creating the familiar teardrop shape of flames. But in space, there was no up for hot gases to rise toward. Instead, the flame formed a perfect sphere, fed only by the slow diffusion of oxygen toward the combustion zone. These space flames burned at lower temperatures because the combustion process was less efficient without convective airflow. The discovery terrified and fascinated engineers in equal measure. Traditional fire detection systems, designed to spot the bright, flickering flames of Earth, might not even notice these ghostly spherical fires. Spacecraft fire suppression systems had to be completely redesigned based on these microgravity experiments. It was a humbling reminder that even something as fundamental as fire, one of humanity's first tools, behaved like an alien phenomenon beyond Earth's gravitational embrace. 94. The art of impossible stillness. Commander Samantha Walsh gently released the pencil and watched it perform magic. In the International Space Station's laboratory module, the yellow pencil hung motionless in mid-air, perfectly still in three-dimensional space. Not floating, that word implied movement. This was pure, impossible stillness. On Earth, even the tiniest air current would send the pencil tumbling. Thermal currents, vibrations, microscopic disturbances, all would conspire to make perfect stillness impossible. But here, 250 miles above the planet, the pencil remained exactly where she had placed it, as if suspended in invisible amber. She could come back tomorrow, next week, even next month, and find it in precisely the same position, assuming no one bumped it or an air circulation fan didn't eventually nudge it. This wasn't weightlessness as science fiction portrayed it, with objects gracefully floating around. This was something more profound, the complete absence of external forces, allowing objects to exist in perfect, crystalline stillness. For astronauts, this phenomenon never stopped being magical. Tools placed in midair became floating workbenches. Food packages became hovering tables. The space station wasn't just a workplace. It was a realm where the impossible physics of perfect stillness made everyday miracles routine. 95. Blood like syrup in the void. Dr. Elena Rodriguez felt different, and the change was literally flowing through her veins. 3 months into her mission aboard the International Space Station, her blood had transformed into something resembling syrup. The familiar fluid that had raced through her circulatory system on Earth now moved sluggishly, thick and viscous, carrying 25% less volume than when she had launched. In microgravity, her red blood cells were changing shape, becoming less efficient at their primary job of carrying oxygen. They were transforming from flexible, disc-shaped cells into rigid spheres that couldn't squeeze through the smallest capillaries as effectively. Her cardiovascular system, evolved over millions of years to fight against gravity, was receiving confusing signals in its absence. Her body interpreted the fluid shift to her upper body as having too much blood volume, so it began destroying red blood cells and reducing plasma production. The result was a kind of space anemia, her blood becoming thicker but less capable of sustaining her. Every heartbeat required more effort to push the syrupy fluid through her vessels. When she returned to Earth, it would take months for her blood to return to normal, relearning how to flow like the river of life it was meant to be. 96. Seeing radiation with your eyes. Astronaut Mark Kelly closed his eyes and saw fireworks. Brilliant flashes of white light exploded across his visual field like cosmic lightning. Even though his eyelids were tightly shut and the space station's laboratory was completely dark, he was experiencing cosmic ray visual phenomena, literally seeing radiation damage happening to his retinas in real time. High-energy particles from deep space, traveling at nearly the speed of light, were piercing the station's hull, passing through his skull, and striking the light-sensitive cells in his eyes directly. Each flash represented a cosmic ray, perhaps from a supernova explosion millions of years ago, hitting his retina with enough energy to trigger the visual neurons normally activated by photons. These weren't hallucinations or tricks of the mind. Kelly was watching subatomic bullets from across the galaxy physically damaging his eyes, one particle at a time. Some flashes were brief sparks, others were long streaks of light that traced the particle's path through his eyeball. The radiation show was beautiful and terrifying, a reminder that space was filled with invisible projectiles capable of altering human DNA. Every astronaut reported these phenomena, making them unwilling witnesses to the universe's most violent events, seen from the inside of their own eyes. 97. When Earth becomes a dot. Astronaut David Scott stared at Earth through the small porthole of Apollo 15 and felt something breaking inside his mind. The blue marble hanging in the infinite black void looked so impossibly small, so fragile, that his entire sense of human importance simply collapsed. He was experiencing Earth out-of-view syndrome, a psychological phenomenon unique to space travel. From this distance, Earth wasn't the massive, solid ground that had defined his entire existence. It was a tiny, delicate ornament suspended in an ocean of nothingness. No borders were visible, no countries, no evidence of the 4 billion people who called it home. The wars, politics, and conflicts that had seemed so important just days ago now appeared absurd when viewed against the cosmic backdrop. Some astronauts reported spiritual awakenings from this perspective. Others experienced existential crises that lasted for years. Many described feeling like they were the only human being in existence, floating alone in a universe too vast to comprehend. The psychological impact was so profound that NASA began including it in pre-flight training. Seeing Earth as it truly is, a small, isolated island of life in an infinite sea of hostile emptiness, fundamentally changed how humans understood their place in the cosmos. 98. The psychology of cosmic isolation. Dr. Jennifer Holt was part of a groundbreaking psychological study, but she didn't know it yet. As mission planners prepared for eventual Mars missions, they were studying something unprecedented. What happens to the human mind when Earth becomes psychologically unreachable? As communication delays increased, first the few seconds to the Moon, then the minutes to Mars, eventually reaching 44 minutes for a round-trip conversation. Something unexpected happened to astronaut crews. They began psychologically detaching from mission control, becoming increasingly resistant to outside help and direction. The delay created more than just communication problems. It fundamentally altered the relationship between space explorers and Earth. When ground control couldn't provide immediate answers to urgent questions, crews learned to rely entirely on themselves. But this independence came with an unexpected side effect. They began to see Earth-based mission planners as outsiders who couldn't possibly understand their situation. Future Mars crews would spend months or years in this state of psychological isolation, essentially becoming autonomous human societies floating in space. The implications were staggering. Humanity's first interplanetary colonists might arrive at Mars having already mentally separated themselves from their home planet, not through distance alone, but through the simple tyranny of time delays. 99. The Accidental Comet Hunter. Dr. Bernhard Fleck never intended to become history's greatest comet hunter. As the project scientist for NASA's Solar and Heliospheric Observatory, SOHO, his mission was crystal clear: study the Sun. The sophisticated spacecraft was designed to monitor solar flares, track sunspots, and understand the nuclear furnace that powers our solar system. But space had other plans. As SOHO stared unblinkingly at the Sun, its sensitive instruments began detecting unexpected visitors. Comets, on their death spiral journeys toward our star, appeared in the spacecraft's field of view like cosmic moths drawn to the ultimate flame. These weren't the spectacular, tail-streaming comets visible from Earth. These were small, doomed icy bodies in their final moments before vaporization. Over 2 decades, SOHO accidentally discovered more than 4,000 comets, more than any other instrument in history, despite never being designed for comet hunting. Amateur astronomers around the world began studying SOHO's images, becoming citizen scientists and discovering dozens of comets themselves. The spacecraft that was supposed to watch the Sun became an unexpected window into the dynamic, violent environment of our inner solar system, proving that sometimes the greatest discoveries come from simply paying attention to what you weren't looking for. 100. Seeing through Venus by accident. NASA's Parker Solar Probe was on a routine mission, using Venus as a gravitational slingshot to adjust its trajectory toward the Sun. The spacecraft wasn't designed to study Venus. It barely had the right instruments for planetary observation. But as it flew past our neighbor world, something extraordinary happened. It accidentally saw through Venus's thick, impenetrable atmosphere. Scientists were stunned when they processed the data. Parker's instruments, designed to study solar wind and magnetic fields, had somehow peered through Venus's dense cloud cover and revealed features on the planet's surface. This should have been impossible. Venus's atmosphere is so thick and opaque that surface features are typically invisible to most instruments. The accidental discovery revealed temperature variations across Venus's surface, showing highland and lowland regions that matched radar maps from previous missions. It was like having X-ray vision for planets, achieved entirely by chance with instruments never intended for the task. The breakthrough opened new possibilities for studying Venus without expensive dedicated missions. Sometimes the most remarkable discoveries happen when we're not even trying to make them, reminding us that space exploration is full of unexpected gifts for those bold enough to venture into the unknown. 101. Reading newspapers on the Moon. The Event Horizon Telescope achieved something that should have been physically impossible. To capture the first image of a black hole's shadow, scientists created a virtual telescope the size of planet Earth, linking radio dishes from Hawaii to Antarctica. The precision required was so extreme that it could theoretically read a newspaper headline on the Moon. The telescope's resolution of 19 microarcseconds represents the absolute limit of what's possible with Earth-based instruments. To put this in perspective, if you placed a donut on the Moon's surface, the Event Horizon Telescope could not only see it, but distinguish its hole from its surrounding pastry. It could read the fine print on a contract signed by an astronaut in a lunar rover. This incredible precision was necessary because black holes are incredibly small when viewed from Earth, despite containing millions of times the mass of our Sun. The black hole at the center of galaxy M87, the subject of the famous first black hole image, appears smaller than a basketball would if placed on the Moon. Creating this level of precision required synchronizing telescopes across the globe with atomic clocks, accounting for Earth's rotation, atmospheric distortions, and relativistic effects, essentially turning our entire planet into a single giant eye capable of seeing the unseeable. 102. Our galaxy's slow-motion journey. Sarah Martinez was celebrating her 30th birthday aboard the International Space Station when she realized something that made her feel dizzy, and it wasn't the microgravity. Since the moment she was born, she had been traveling through space at 514,000 miles per hour without ever knowing it. Earth, along with the entire solar system, was racing around the Milky Way galaxy at this incredible speed, completing one full orbit every 200 million years. During her 30 years of life, she had traveled 135 billion miles through intergalactic space, a distance so vast it boggled comprehension. But here was the truly mind-bending part. Since Earth formed 4.5 billion years ago, our planet had completed only 22 trips around the galaxy. When dinosaurs ruled the Earth, our solar system was on the completely opposite side of the Milky Way. The stars that ancient humans used for navigation were in entirely different positions relative to our cosmic neighborhood. From her vantage point above Earth, Sarah realized she was riding on a planet that was itself riding on a star that was racing through a galaxy spinning through an expanding universe. Every moment of her existence was actually a high-speed journey through the cosmos, making her both a terrestrial being and a cosmic voyager simultaneously. 103. Diamond Stars in the Darkness. Dr. Williams never imagined she would discover a diamond the size of Earth floating in space, but that's exactly what her team found hidden in the constellation Centaurus. What appeared to be an ordinary white dwarf star was actually something far more extraordinary. A crystallized stellar corpse transformed into the universe's largest gemstone. When massive stars exhaust their nuclear fuel, they collapse into white dwarfs, Earth-sized objects containing the mass of an entire star. As these stellar remnants cool over billions of years, their carbon and oxygen cores begin to crystallize under the immense pressure, forming a structure identical to diamond. The white dwarf BPM 37093, nicknamed Lucy, after the Beatles' song Lucy in the Sky with Diamonds, contains about 10 billion trillion carats of diamond. If it could somehow be mined and brought to Earth, it would crash the global diamond market instantly. This single cosmic gem contains more diamond than has ever existed in human civilization. These diamond stars are among the oldest objects in the universe, having spent billions of years slowly cooling and crystallizing in the cold depths of space. They represent the final fate of stars like our Sun. Not destruction, but transformation into cosmic jewels that will outlast entire galaxies. 104. Radio bursts from dead galaxies. Dr. Amanda Chen thought she had made an error in her data analysis. The fast radio burst she was studying appeared to be coming from an old, dead elliptical galaxy, exactly the kind of place where such energetic explosions shouldn't exist. Fast radio bursts were supposed to originate from young, active galaxies filled with newborn stars and violent stellar deaths. The radio telescope had detected a burst lasting mere milliseconds but containing more energy than our Sun produces in an entire day. These cosmic flashes had been observed before, but always from galaxies teeming with star formation and magnetic activity. This signal, however, was coming from a galaxy that had stopped forming stars billions of years ago, a cosmic retirement community with no business producing such violent outbursts. The discovery forced astronomers to completely reconsider what creates these mysterious signals. If dead galaxies could produce fast radio bursts, then the universe was far more dynamic and unpredictable than anyone had imagined. Perhaps ancient neutron stars were somehow reactivating after eons of dormancy, or maybe entirely unknown phenomena were at work. The implications were staggering. The universe's most enigmatic signals might be coming from precisely the places scientists thought were quiet and stable, suggesting that even in cosmic death, spectacular violence could suddenly erupt. 105. Photographing the universe's skeleton. In early 2025, Dr. Raja Patel achieved something that astronomers had dreamed about for decades. She captured the first detailed photograph of the cosmic web, the vast network of dark matter filaments that connects galaxies across the universe like a three-dimensional spider web spanning billions of light years. Using the James Webb Space Telescope's unprecedented infrared vision, her team identified a single cosmic web filament stretching 3 million light-years through space, connecting distant galaxies when the universe was only 2 billion years old. This invisible scaffold of dark matter and gas represents the universe's fundamental architecture, the skeleton upon which all cosmic structure is built. The filament appeared as a faint stream of hydrogen gas, illuminated by the ultraviolet radiation from nearby galaxies. It was like seeing the universe's circulation system for the first time, revealing how matter flows between galaxies along these cosmic highways. The discovery showed that even in the early universe, this vast web was already in place, channeling matter from empty voids into the dense nodes where galaxies formed. For the first time in human history, we could actually see the universe's hidden blueprint, the invisible framework that determines where galaxies live and how they're connected across the vast emptiness of space. 106. The largest structure defies physics. Dr. Sarah Kim stared at her computer screen in disbelief. The data from the Planck satellite showed something that shouldn't exist according to current physics. A cloud of energetic particles surrounding galaxy cluster PLCK G287.0 plus 32.9 that stretched nearly 20 million light-years across, larger than the distance between the Milky Way and the Andromeda Galaxy. This wasn't just big, it was impossibly big. Current models of cosmic ray physics suggested that high-energy particles should lose their energy and fade away long before reaching such enormous distances from their source. Yet somehow, this cosmic leviathan was maintaining its energetic particles across distances that defied theoretical predictions. The discovery challenged fundamental assumptions about how energy propagates through space. These particles should have radiated away their energy millions of years ago, yet they remained mysteriously energetic across a volume of space containing hundreds of galaxy clusters. It was like finding a campfire that somehow stayed hot across an entire continent. The implications were staggering. Either scientists had fundamentally misunderstood how particles behave in cosmic magnetic fields, or some unknown mechanism was continuously re-energizing these particles across truly cosmic scales. The universe had revealed a structure so large and energetic that it broke the rules of physics as we understood them. 107. Countdown to cosmic fireworks. Just 150 light-years from Earth, practically next door in cosmic terms, two white dwarf stars are locked in a deadly spiral dance that will end in one of the most spectacular explosions visible from our planet. Dr. Elena Rodriguez had discovered what astronomers call a cosmic time bomb, and the fuse was rapidly burning down. The two stellar corpses, each roughly the size of Earth but containing nearly the mass of our Sun, are orbiting each other so closely that they complete a full orbit in just 40 minutes. They're so close that matter is streaming from one star to the other in a brilliant spiral of superheated gas, gradually increasing the mass of the receiving star. When that star reaches a critical mass threshold, about 1.4 times the mass of our Sun, it will explode as a Type Ia supernova. The explosion will be so bright it will appear as a new star in Earth's sky, shining 10 times brighter than any current star and visible even in broad daylight for weeks. This cosmic fireworks show is inevitable, but the timing remains uncertain. It could happen tomorrow or in a million years. When it does occur, humans will witness one of the universe's most violent events from a front-row seat, safely distant but close enough to appreciate the awesome power of stellar death. 108. The ocean cemetery of spacecraft. Deep beneath the Pacific Ocean, in one of the most remote locations on Earth, lies humanity's strangest graveyard. Point Nemo, the oceanic pole of inaccessibility, is farther from land than the International Space Station is from Earth's surface. And it's here that more than 300 spacecraft have been deliberately crashed and now rest on the ocean floor in what's officially called the Spacecraft Cemetery. When satellites and space stations reach the end of their operational lives, engineers face a crucial decision. Where should these multi-ton chunks of metal and electronics crash back to Earth? The answer is Point Nemo, located 2,688 kilometers from the nearest landmass in the South Pacific. This remote patch of ocean has become the final resting place for everything from Russian Mir space station modules to European cargo vessels. The largest resident of this underwater necropolis is the Russian Mir space station, deliberately deorbited in 2001 after 15 years in space. As it plunged through Earth's atmosphere, most of it burned up in a spectacular fireball, but the remaining fragments, including its massive core module, crashed into the Pacific and now rest 4,000 meters below the surface. It's a sobering reminder that what goes up must come down, and humanity's reach for the stars leaves a permanent mark on our own planet. 109. Jupiter's invisible magnetic mystery. NASA's Juno spacecraft had been orbiting Jupiter for 3 years when it discovered something that shouldn't exist: a massive magnetic anomaly near the planet's equator that scientists dubbed the Great Blue Spot. Unlike Jupiter's famous Great Red Spot, a storm system visible for centuries, this magnetic feature was completely invisible to optical telescopes but incredibly powerful. The magnetic anomaly is unrelated to Jupiter's atmospheric storms and appears to be generated deep within the planet's interior. It's a region where Jupiter's magnetic field is significantly different from the surrounding areas, creating a blue signature when mapped by Juno's magnetometer. The discovery suggested that Jupiter's magnetic field is far more complex and dynamic than scientists had realized. What makes the Great Blue Spot particularly puzzling is that it doesn't align with any known atmospheric or interior processes. It's as if Jupiter has a hidden magnetic engine generating a powerful field in isolation from the planet's other magnetic systems. The anomaly challenges current models of how gas giant magnetic fields are generated and maintained. This invisible magnetic monster demonstrates that even in our own solar system, worlds we've studied for centuries can still harbor fundamental mysteries hiding just beneath the surface of our understanding. 110. Mercury's Eternal Shrinking Act. Dr. Jennifer Walsh was studying images from NASA's Messenger spacecraft when she noticed something extraordinary: fresh fault scarps on Mercury's surface that looked surprisingly recent. These cliff-like features, some hundreds of miles long and more than a mile high, were evidence that Mercury was still shrinking, 4.5 billion years after its formation. As Mercury's interior gradually cools, the planet contracts like a deflating balloon. The surface cracks and buckles, creating massive fault systems that crisscross the planet like wrinkles on aging skin. But what shocked scientists was the discovery that this process was still actively occurring. The fault scarps showed clear evidence of recent geological activity. Some of them cut across impact craters, proving they formed after the craters, potentially within the last 50 million years, which is geologically recent. This tiny world, closest to the sun and subjected to extreme temperature variations, is literally shrinking before our eyes. Mercury has contracted by approximately 7 kilometers in radius since its formation. Imagine if Earth suddenly became 14 kilometers smaller in diameter. This ongoing shrinkage makes Mercury one of the most geologically active worlds in the inner solar system, despite having no atmosphere, no water, and no plate tectonics. It's a reminder that planetary evolution continues over cosmic timescales, transforming worlds in ways we're only beginning to understand. 111. We are ancient stardust. Dr. Maria Santos held the meteorite fragment in her gloved hands and felt a profound connection to cosmic history. Every atom in her body heavier than hydrogen and helium, the carbon in her DNA, the calcium in her bones, the iron in her blood, had been forged in the nuclear furnaces of dying stars billions of years ago. The realization was both humbling and extraordinary. The carbon that formed the backbone of every molecule in her body had been created when a massive star, perhaps 20 times larger than our sun, reached the end of its life and began fusing lighter elements into heavier ones. When that star exploded as a supernova, it scattered these precious elements across space in a cosmic explosion that outshone entire galaxies. The iron in her blood had been created in an even more violent process, either in the core collapse of a massive star or in the collision of two neutron stars. These cosmic catastrophes had forged the heavy elements and hurled them into the cosmos, where they eventually became part of the molecular cloud that gave birth to our solar system. Looking at her hands, Maria realized she was quite literally made of ancient starlight, a collection of stellar ashes that had somehow organized itself into consciousness and was now contemplating its own cosmic origins. Every human being was a walking testament to the universe's ability to transform stellar death into biological life. 112. The universe's loneliest galaxy. In the vast emptiness of space, galaxy MCG plus 0102-015 exists in a state of isolation so profound it defies comprehension. Dr. Ahmed Hassan discovered this cosmic hermit during a survey of distant galaxies, and what he found challenged everything astronomers thought they knew about galaxy formation and evolution. This galaxy is so isolated that light from its nearest neighbor would take 100 million years to reach it, a distance so vast that when the light began its journey, complex life on Earth was just beginning to emerge from the oceans. If you lived in this galaxy and looked out at the night sky, you would see no other galaxies whatsoever. The universe would appear empty except for your own cosmic island. The isolation raises fundamental questions about how this galaxy formed. Most galaxies exist in groups or clusters, shaped by gravitational interactions with their neighbors. But MCG plus 0102-015 has evolved in complete solitude, making it a unique laboratory for understanding what happens when galaxies develop without external influences. Perhaps most remarkably, despite its isolation, the galaxy appears structurally normal. It has spiral arms, a central bulge, and ongoing star formation. This lonely galaxy proves that not all cosmic evolution requires cosmic company, and somewhere in the universe, entire civilizations might exist believing they are utterly alone in an empty cosmos. 113. The controversial death of dark matter. Dr. Rachel Thompson's 2024 research paper sent shockwaves through the astronomical community by suggesting something radical. Dark matter, the mysterious substance thought to comprise 27% of the universe, might not exist at all. Instead, she proposed that fundamental forces themselves weaken over cosmic time, eliminating the need for invisible matter to explain galactic behavior. Her alternative theory, called weakening gravity, suggested that the force of gravity gradually becomes less strong over billions of years. This would explain why galaxies appear to have more mass than we can see. Not because of invisible dark matter, but because gravity behaved differently in the early universe when those galaxies formed. The implications were staggering. If true, it would mean that decades of searching for dark matter particles had been pursuing a phantom. The massive underground detectors, space-based observatories, and particle accelerators dedicated to finding dark matter would have been looking for something that never existed. However, the theory faced intense scrutiny from the scientific community. Dark matter had successfully explained numerous observations, from the cosmic microwave background to the formation of large-scale structure. Thompson's work represented either a revolutionary breakthrough or a fundamental misunderstanding of cosmic physics. The debate highlighted how much we still don't know about the universe, and how even our most basic assumptions about reality might be wrong. 114. Stars powered by dark matter. Deep in the early universe, when galaxies were just beginning to form, there may have existed stars unlike anything we see today, massive objects powered not by nuclear fusion, but by the annihilation of dark matter particles. Dr. Catherine Fries proposed that these dark stars could explain some of the mysterious observations from the James Webb Space Telescope. These theoretical objects would have been enormous, potentially 10 million times more massive than our Sun and millions of times brighter. Instead of the nuclear fusion that powers normal stars, dark stars would have been sustained by dark matter particles colliding and annihilating each other, releasing tremendous amounts of energy. The dark matter fuel would have allowed these stars to grow to impossible sizes without collapsing under their own gravity. They could have existed for millions of years, growing larger and brighter as they consumed the dark matter surrounding them in the early universe's dense environment. If these dark stars really existed, they could explain how supermassive black holes formed so early in cosmic history. When the dark matter fuel was finally exhausted, these massive objects would have collapsed directly into the first generation of black holes, seeding the centers of the earliest galaxies. Webb's detection of surprisingly massive early galaxies might actually be observations of these dark matter-powered giants, representing a completely unknown phase of stellar evolution that occurred only in the universe's youth. 115. The mystery of little red dots. Dr. Stephen Johnson was scrolling through James Webb Space Telescope data when he noticed them. Thousands of tiny red objects scattered across deep space images like cosmic confetti. Initially dismissed as small, distant galaxies, these little red dots turned out to be something far more mysterious and significant. Further analysis revealed that these compact objects weren't normal galaxies at all. They were powered by actively feeding supermassive black holes in the early universe. Each red dot represented a black hole millions of times more massive than our Sun, gorging itself on surrounding matter and shining brighter than entire galaxies despite being incredibly compact. The discovery was revolutionary because it suggested that supermassive black holes were far more common in the early universe than anyone had imagined. These weren't rare monsters at the centers of massive galaxies. They were everywhere, scattered throughout space like cosmic streetlights illuminating the young universe. The red color came from the extreme redshift of their light, stretched by the expansion of the universe over billions of years. What appeared red to Webb's instruments was actually brilliant blue-white light emitted when the universe was less than 1 billion years old. These little red dots fundamentally changed our understanding of early cosmic evolution, suggesting that the universe's first billion years were dominated by black hole activity on a scale previously unimaginable. 116. Challenging the Big Bang's evidence. Dr. Elena Volkov's controversial 2025 calculations suggested something that would have been considered heretical just years earlier. The cosmic microwave background radiation might not be the pristine relic of the Big Bang that scientists had believed for decades. Instead, early massive galaxies might have contributed significantly to this fundamental piece of evidence for our universe's origin. The cosmic microwave background, CMB, has long been considered the afterglow of the Big Bang, radiation left over from when the universe first became transparent to light. Its nearly perfect uniformity across the sky, with tiny fluctuations that seeded galaxy formation, has been the strongest evidence supporting Big Bang cosmology. But Volkov's team found that if the early universe contained more massive galaxies than previously thought, as suggested by recent Webb telescope observations, these ancient stellar systems could have contributed their own radiation to what we observe as the CMB. This contamination would mean that the CMB doesn't purely represent conditions 380,000 years after the Big Bang. The implications were profound. If the CMB had been significantly altered by early galactic activity, then one of cosmology's most trusted pieces of evidence might be telling a more complex story than scientists realized. It wouldn't necessarily invalidate the Big Bang theory, but it would require a major revision of our understanding of the universe's first billion years. The scientific community remained divided, with many arguing that the theory couldn't explain all CMB observations. 117. Gravitational waves as cosmic architects. In a groundbreaking 2025 theory that challenged decades of cosmological thinking, Dr. James Rodriguez proposed that gravitational waves, ripples in spacetime itself, were the true architects of cosmic structure. His radical idea suggested that these waves, generated by violent events in the very early universe, were responsible for seeding the formation of the first galaxies. Traditional cosmology relied on cosmic inflation, a hypothetical period of exponential expansion that could never be directly observed. Rodriguez's theory offered an alternative. Instead of inflation, primordial gravitational waves from colliding black holes or phase transitions in the early universe created the density fluctuations that eventually became galaxies. The beauty of this theory was that gravitational waves were real, observable phenomena. Unlike the speculative inflation field, scientists could actually detect and study gravitational waves using instruments like LIGO and Virgo. If Rodriguez was correct, then the cosmic architecture we observe today was built by the same type of spacetime ripples that modern detectors routinely observe. His calculations showed that these primordial gravitational waves could create exactly the type of density patterns observed in the cosmic microwave background and large-scale structure. It was a theory that replaced unobservable physics with phenomena that could be studied in detail. The implications were revolutionary. The universe's grandest structures might be the result of spacetime itself vibrating like a cosmic drum in the moments after creation. 118. SpaceX's revolutionary economics of failure. Elon Musk watched his fourth Starship prototype explode in a spectacular fireball and smiled. While traditional aerospace companies would have considered this a catastrophic failure requiring years of investigation, SpaceX's entire philosophy was built around what they called controlled explosions and rapid iteration. The economics were revolutionary. SpaceX's entire Starship development program, including dozens of spectacular failures, cost less than a single traditional NASA mission. While NASA's space launch system required over a decade and $20 billion to reach its first launch, SpaceX was exploding and rebuilding Starship prototypes every few months for a fraction of the cost. This fail fast, learn faster approach represented a fundamental shift in aerospace engineering. Instead of spending years on computer models and ground tests to ensure perfect first flights, SpaceX built real hardware, pushed it to failure, learned from the explosion, and immediately began building the next iteration with improvements. Each spectacular explosion was actually a data-gathering exercise. High-speed cameras captured every moment of structural failure, providing insights that computer simulations could never replicate. Engineers learned exactly how materials behaved under extreme stress, how engines failed, and how to build better systems for the next attempt. The strategy was transforming space exploration from a cautious, decades-long process into a rapid-fire development cycle that could achieve breakthroughs in years rather than generations. 119. The Moon Missions that Bankrupted Nations. Standing in the Smithsonian Air and Space Museum, Dr. Sarah Williams calculated something that made her dizzy. Each Apollo moon landing had cost approximately $25 billion in today's dollars, more than the entire annual GDP of countries like Finland or New Zealand. The Apollo program's total cost of $283 billion represented one of the largest peacetime expenditures in human history. To put this in perspective, the United States spent more money getting 12 humans to the moon than most countries produce in economic output during an entire year. Each astronaut who walked on the lunar surface represented an investment of over $23 billion. Enough money to fund entire university systems, build transcontinental railways, or eliminate poverty in small nations. The scale was so enormous that some economists argued it actually helped trigger the economic problems of the 1970s. The massive government spending on Apollo, combined with the Vietnam War, contributed to inflation and budget deficits that plagued the U.S. economy for years afterward. Yet the investment paid dividends far beyond moon rocks and national pride. Technologies developed for Apollo led to integrated circuits, lightweight materials, miniaturized computers, and countless innovations that transformed civilian life. The Apollo program essentially kick-started the digital age, making the enormous cost an investment in humanity's technological future. Still, the price tag served as a sobering reminder of what it truly costs to reach beyond our planet. 120. The Impossible Ancient Black Hole. Dr. Rebecca Chun stared at the James Webb Space Telescope data in disbelief. The black hole she was observing had existed just 440 million years after the Big Bang, when the universe was only 3% of its current age, yet it already contained 9 million times the mass of our Sun. According to every model of black hole formation, this should have been impossible. Black holes grow by consuming matter, but there are limits to how fast they can feed. The Eddington limit describes the maximum rate at which a black hole can accrete material before the radiation pressure from its feeding frenzy blows away incoming matter. Even growing at this maximum rate continuously since the Big Bang, a black hole shouldn't have been able to reach such enormous mass so quickly. The discovery forced astronomers to reconsider fundamental assumptions about the early universe. Either black holes could somehow grow faster than physics allowed, or the universe's first black holes started much larger than anyone had imagined. Perhaps they formed directly from the collapse of massive primordial gas clouds, bypassing the normal stellar evolution process entirely. This ancient monster challenged the entire timeline of cosmic evolution. If such massive black holes existed when the universe was still in its infancy, they would have profoundly influenced the formation of the first galaxies, potentially explaining how complex cosmic structures appeared so surprisingly early in universal history. 121. The Big Wheel that Defies Probability. When Dr. Amanda Foster first spotted the Big Wheel galaxy in James Webb Space Telescope data, she thought there had been an error in the image processing. This disk galaxy from the early universe was 3 times larger than any comparable galaxy from its era and spun as fast as modern superspiral galaxies, a combination that should have been virtually impossible. The galaxy existed when the universe was only 1.5 billion years old, yet it displayed characteristics that astronomers thought required billions more years to develop. Its massive size and rapid rotation suggested it had somehow fast-tracked through evolutionary stages that typically took 6 to 8 billion years to achieve. Statistical analysis showed that the probability of finding such a galaxy was less than 2% according to current models of cosmic evolution. It was like discovering a fully grown oak tree in a forest of saplings. Not just rare, but fundamentally challenging to our understanding of how galaxies grow and mature. The Big Wheel's existence suggested that the early universe was far more dynamic and capable of rapid development than scientists had realized. If galaxies could achieve such size and complexity so early, then the entire timeline of cosmic evolution might need to be rewritten. The discovery joined a growing list of impossible early galaxies found by Webb, each one forcing astronomers to expand their ideas about what was possible in the universe's youth. 122. The Gold Mystery of Cosmic Collisions. Dr. Lisa Park was analyzing gravitational wave data from neutron star collisions when she discovered something that violated everything scientists thought they knew about these cosmic catastrophes. Some mergers were producing significantly more gold than theoretical models predicted. In some cases, more gold than should have been physically possible given the masses of the colliding stars. Neutron star collisions, or kilinovae, were supposed to be well-understood events. When two ultradense stellar remnants spiral into each other, the extreme conditions forge heavy elements like gold and platinum through rapid neutron capture. The amount of gold produced should be directly related to the total mass of neutron-rich material involved in the collision. But the observations didn't match the theory. Some mergers with relatively small neutron stars were producing gold yields that would require much more massive objects. It was as if the universe had found a way to create something from nothing, violating conservation of mass and energy. The mystery deepened when scientists realized they might be fundamentally misunderstanding what happens during these mergers. Perhaps the collisions triggered unknown nuclear processes, or maybe some neutron stars contained exotic matter that behaved differently than normal atomic nuclei. Each new gravitational wave detection added to the puzzle, suggesting that humanity's understanding of matter's most extreme states was still incomplete, even for processes we thought we had mastered. 123. Webb's first direct planet portrait. In a historic achievement, the James Webb Space Telescope captured its first direct image of an exoplanet candidate, TWA-7b, a Saturn-mass world orbiting a young star system 200 light-years away. Dr. Kevin Thompson realized he was looking at something unprecedented. The lightest planet ever directly photographed outside our solar system. Direct imaging of exoplanets is extraordinarily difficult because planets are billions of times fainter than their host stars. It's like trying to photograph a firefly next to a searchlight from thousands of miles away. Most exoplanets are discovered indirectly through their gravitational effects on their stars or by the slight dimming they cause when passing in front of their stars. But TWA-7b was different. The planet orbited far enough from its star that Webb's sophisticated coronagraph could block the stellar light and reveal the planet's own faint glow. The direct image showed the planet's thermal emission, heat left over from its formation glowing in infrared light. This wasn't just a technical achievement. It was a preview of humanity's future. Direct imaging allows scientists to study exoplanet atmospheres in detail, potentially detecting signs of life through atmospheric chemistry. TWA-7b represented the first step toward photographing Earth-like worlds around other stars. The image marked a new era in exoplanet science, where astronomers could finally see distant worlds as more than just statistical blips in data. They could photograph them as real places. 124. The surprising fullness of empty space. When Voyager 1 and 2 crossed into interstellar space, the region between star systems, NASA scientists expected to find near-perfect emptiness. Instead, Dr. Elena Rodriguez analyzed data showing that empty interstellar space was surprisingly full of complex phenomena that challenged assumptions about what lies between stars. The probes discovered that interstellar space contained intricate magnetic field structures, unexpected particle densities, and dynamic plasma environments. Rather than the static, uniform medium scientists had expected, the region between stars was alive with magnetic turbulence, shock waves from ancient supernovas, and charged particles accelerated to incredible speeds. Most surprisingly, the local interstellar medium through which our solar system travels contained about 1 atom per cubic centimeter, sparse by Earth standards, but denser than expected. These atoms weren't randomly distributed but organized into complex structures influenced by the magnetic fields of nearby stars and the remnants of stellar explosions. The Voyager data revealed that interstellar space has weather, dynamic changes in density, temperature, and magnetic field strength that vary over timescales from years to centuries. Our solar system wasn't traveling through empty void, but through a complex, ever-changing cosmic environment. The discoveries fundamentally changed how scientists think about the spaces between stars, revealing that even the universe's seemingly empty regions are filled with invisible complexity and dynamic processes. 125. The universe's lopsided expansion. Dr. Patricia Kim made a discovery in 2025 that shook the foundations of cosmology. The universe's expansion isn't uniform in all directions. Using data from multiple space telescopes and supercomputer simulations, her team found that space itself expands at measurably different rates depending on which direction you look. This cosmic asymmetry violated one of the fundamental assumptions of modern cosmology, that the universe appears the same in all directions when viewed on large scales. If confirmed, it would suggest that our universe exists within some kind of larger superstructure, or that our understanding of cosmic expansion is fundamentally flawed. The effect was subtle but unmistakable. In some directions, galaxies appeared to be receding slightly faster than expected, while in others they moved slightly slower. The difference was only about 1%, but in cosmology, even tiny deviations from perfect uniformity can indicate profound underlying physics. The discovery raised mind-bending possibilities. Perhaps our universe is embedded in a higher dimensional space that influences expansion rates, or maybe we're observing the gravitational effects of matter beyond our observable horizon. Some theorists even suggested we might be seeing evidence that our universe is just one bubble in a vast cosmic foam of multiple universes. If the universe's expansion truly is directional rather than uniform, it would require a complete revision of cosmological models and our understanding of space, time, and the nature of reality itself.